What's up, everybody? Sorry we're a little bit late. I just ran up the stairs, so I'm out of breath. I ran up the stairs, then down the stairs, then back up the stairs again, but I'm here. Welcome. Ignore what you see on the screen right now. I found a new Linux distribution and I could not wait to install it because it looks pretty cool. So I'm just going through and I'm just installing it. I'm trying to figure it out. But what's up, everyone? Good to see you all. It's Mainzy. Welcome. Exegete, you were actually first today. Good to see you. Absolutely, send it to your peers. This is a good one that everybody in tech needs to know. What's up, Propagation Nation? Missed in the pipelines. I get it. I get it. Take your time. You know, it happens like that. I definitely understand. It'll go up pretty soon. We had a good baby shower. It was fun. Had a good time. AI Luna, thank you so much for the tier 1 sub. Appreciate all the support from you, for sure. What's up, Velusip? Good to see you. Not yet. No, soon, very soon. Good to see you. Was there a pie baby? No, there was not a pie baby. Not yet. Not yet. We're still on baby watch for sure. So what distro is this? I'll tell you about this in a second. It's called Garuda. I know it's really small. I'll make it larger for you in a second. I wanted to get it up and running before. Well, first off, I found it 10 minutes ago. I'm not lying to you. I found it right before I went live and I downloaded it immediately because I was like, we might need to use this. So we're gonna see if we can get it up and running in a second. We'll have it run in the background. Today, it's not a big deal what we use for this at all, but it's called Garuda. It's called Garuda Linux and it's Arch-based. It's an Arch-based distribution that tailors the desktop experience. There's a bunch of different flavors of it. I can show you the link to it in a second. Yeah, Git class. Get knowledge 100%. I feel you. Hype train incoming. I love it. Thank you so much, Exegete, for the 1,000. Lost a bet then. That's fair. I appreciate it. I mean, I'm not gonna lie. I believed it sounded feasible, but at this point though, I'm actually thinking the baby's not gonna come until my birthday. So my birthday is on the 21st. I actually didn't realize how close it was to 21st because I'm not thinking about my own birthday because I'm bringing a new person into the world. Well, I'm not bringing anyone into the world. My wife is bringing a new little one into the world. And 21 is an important number for us. 321, 621. My birthday is 321. My wife's birthday is 621. Exactly 3 months after me. We're the same age, but we've been seeing the number 21 a lot lately, and it's just, we can't ignore it. So I think that the baby and I might in fact share a birthday. So we'll see. That would be a nice little, that'd be a nice gift. I know that some people say, oh, you don't want to do that. You'll lose your birthday forever. One, I don't really care about my birthday. Two, that's not true. That just means me and my child will get to have dope double birthdays. And when I say double birthdays, I don't mean the kid's birthday with some adults there. I mean double birthday, okay? We'll both have all of our friends. We'll both be doing the same exact activities. So it should be pretty fun. But it's good to see everybody. What's up, Boris? Finally get to watch live? Absolutely. So let me put in a password here to see my little throwaway password that I like to use for my VMs. Let me see if I can get it running. But yeah, this just looks like a cool little distro. I'll let it install for now, and then I'll minimize it for now. We'll see what we can do with it. But welcome to day 1 of Tracks, a 3-part Git series. Should be pretty fun, and we should be able to get through it in 3 days, no problem. It was 4 parts before. This time it'll be 3, so that we can do not only this, but on Thursday we will start Waddle. So I'm about to release the teaser again. I'll just re-release the teaser for that, just to change the information. And I wanted to see if I could actually condense it down to 3 days. That one will feel a lot more rushed than this one will feel. And usually we try to do that one first because if you don't have command line skills or you don't have that familiarity, this is a little bit tougher, but I think we should be good. You can completely understand everything we're doing today without needing to know much about the command line, even though we will be doing everything from the command line. So you were late today, but because of daylight saving, I was almost an hour early. Yes, happy daylight savings time, everyone. I hope, I'm doing okay. I have asked my wife to bring me a cup of coffee because I was late, not because, I asked her to bring me a cup of coffee. And so she's so graciously gonna be so kind and bring me one because I need, this hour is throwing me off. It's throwing me off a lot. And yeah, it's gonna take me a little bit to get comfortable with it. It's still light outside. It did exactly what it's supposed to do. It saved some daylight. But yeah, it should be, eventually. It'll take me a couple weeks to get used to it. All right, so what I want you to do is first, go ahead and hit !slides if you want to get the slides. So that will give you the slides for tonight. There are a fair amount. I spelled slides wrong. There we go. And I clicked on that in the wrong thing. Let me do it down here. Let me copy this URL and do it on this computer here. And let's head over and let's see. Let's just check on this periodically. I just want to see. I really want to try this thing out. I'm hoping it's done by the time we get to the part of the slides where we need to start doing some stuff hands-on. I kind of want to see if what this looks like. What's up all day? It's good to see you. Amame, welcome. It's good to see you today, man. My cell tower's in the wrong time zone, so I got up an hour early yesterday. Ooh, that would have bothered me. I live in America, New York time zone, Eastern time. So it is it's currently 7 p.m. where I am, 7:08 p.m. where I'm at now. I'm on the East Coast of the United States. Live in Germany. What time is it? What's up, Skill Killer? What time is it in Germany? I'm wondering. What's up, Hamdi? How you doing? All right, so we are gonna go ahead and get started so that we have time to get through everything. Again, I actually think this is a better course combined down into 3 days. I mean, combined into just 3 days instead of 4 days. It says day 1 of 4. Let me update that because we did do it in 4 parts the first time. But now it is just gonna be 3 this go around. Come on, view only. Hold on, let me get a little refresh going. All right, it's 12 a.m. Okay, all right. What's up, CC? Good to see you. All right, so 1 of 3. Let's get going with this one. So what are today's topics when we're talking about tracks, the Git Masterclass? Well, we want to first understand what in the world is version control. You might not know what that is right now, but you'll understand what it is in just a few minutes. But we'll also learn about what Git is. We'll dive into some Git terminology. You need to be comfortable, or not need to be comfortable, but you need to get introduced to the terms, all the different words, all the different ways that we talk about things that are happening. You need to understand what those are. We'll talk about Git hosting and GitHub. GitHub is a Git hosting platform, but we'll talk about the differences there, and we'll talk about GitHub itself. We'll dive into GitHub. If you don't already have an account, you will have an account after today. We'll talk about the basic Git workflow. We'll talk about cloning, branching, and tagging. So you will get hands-on today. You will be able to push up your first repository if this is your first time diving into it. Also, if you want to hit ! tracks and you're unsure of what we're going to be learning in the other 2 parts, today is going to be the quick basics. Not quick basics, but we'll be diving into the basics, and then it'll get a little more, we'll get a little more advanced, and we'll dive into a lot of other pieces. And so I think we should go over that real quick, just so you know what you should expect for the next 2 days. What's up, R1? Welcome. Thank you so much again, Velusa. Thank you so much for following. What's up, Bang? Welcome to the channel. Rechargeable Cyborg, welcome to the channel as well. Thank you so much for the follow. All right, so we're gonna be diving in. After today, we're gonna learn all the things that you just saw. Tomorrow we're gonna talk about SSH and HTTPS and learn about SSH keys. And we'll talk about doing diffs and how do you compare what's different, how do you know what's going on there. We'll talk about fetching and pulling. I think we might talk about fetching and pulling today a little bit as well. PRs, merging and forking, and how you contribute to open source. In day 3, we'll talk about some, reverting, reset, rebase, but we won't just talk about these things. We're actually going to do these things: cherry picking, conflict resolution, stashing. I'll have a repository for you that will have a bunch of information in it for this as well, so that you can do exactly what I do with the same repository if you need to. But yeah, so that's what you're going to learn in these 3 parts. It should get you more than enough so that you feel comfortable enough using Git to do great things. I will say this right now, right up front: Git is one of the most interesting technologies. It's one of the most important. It's one of the ones that's easiest to get started with, but one of the hardest to master. If you think you are amazing at Git, you probably don't know enough about Git yet, and you will run into issues often. Today will seem easy. And then day 2 might be fine too. Day 3, it'll get to the really confusing things. And so I just want you to be aware. Don't leave this today feeling like you know Git really well, and then a month from now you get into a situation at work and you're like, oh man, I really don't know Git. It's okay. Everyone's like that, 100%. So don't sweat it. We'll learn what it is. We'll learn what it does, and that will help you move forward in the future. All right. Thank you. I'm good. Thank you. There we go. Is day 2 tomorrow or next Monday? Day 2 is tomorrow. We're doing it 3 days in a row. We never do that, but we're doing it 3 days in a row. Today, tomorrow, and Wednesday. What's up, Idealo? Welcome. So, let me take a sip of coffee, and then I'll say time to dive. Hold on. Time to dive in. It's actually not. My settings are wrong. But time to dive in. Whatever. There we go. What in the world is version control? Well, version control systems. These are a category of software tools that help a software team manage changes in source code over time. What is source code? If you weren't a part of Decoded, source code is simply the human readable code that we write. So when we're programming, when we're coding, we are writing source code, okay? And version control allows you to track changes that a team makes over time. You've seen this before many times, but it's pretty cool. So just a little bit more about version control is it keeps track of every modification in the source code. Now, think about that, Think about that, modification. So when things change, that's what it tracks. It tracks changes. So when a modification is made, it's saved in a special kind of database. You don't need to worry about that piece yet. But if a mistake is made, so this is one of the benefits, is that when a mistake is made, a developer can turn back the clock and compare an earlier version of the code to help fix the mistake while minimizing disruptions to the team members. So what version control does in terms of software is when we're writing this code, it allows us to be able to understand what's happening and to track the changes that are made across the code base so that we can solve problems. When we need to solve problems, we can fix issues when things have changed. So we can always go back and see what happened in the order that they happened. And it gives you more insight into the history of a code base. All right, so version control just helps us know what version of code that we're at so that we can move forward effectively or roll back effectively if we need to. Time travel for code, I like it. Yes, it can be, absolutely. So that's what version control is. And I want you to think right now about, we're right here inside of Google Docs, but it says the last edit to this was 6 minutes ago. So I moved some slides over 6 minutes ago from part 2, and look at these are different versions of this document. Okay, so this is a type of version control, but when we're talking about version control for software, it works a little bit differently, but this is quite similar in the way that it works. We have these, like, in your Microsoft Word, you can always go back and retrieve previous versions so that you can see what changes were made. And it's super helpful, if you should turn the computer off before you're ready or something like that, or you deleted something you didn't mean to delete, it helps you go back and get those things. And so we're talking about how to do this specifically for code today. Scott Hizimo, thank you so much for the raid, or for the host. I appreciate it. Welcome. Okay, so that's version control. But what is Git? All right, why are we talking about version control when today is about Git? Well, a lot of words here. We're gonna read it and we're gonna break it down. So Git is a distributed, that's the first key word. And actually, we're gonna go in here right now and we are going to bold this. I like this. Distributed, extra bold, even though it's not extra bold. Let's italicize it as well, just so we can make sure we know what it is. Six Figure Dev, welcome to the channel tonight. Thank you so much for the raid. First off, shout out to Six Figure Dev. That's good timing right there. It's good to see you. What's up, Code with Sean? I hope you all had a great stream today. Welcome, come on in. We're just getting started on a 3-part Git series. And we're just learning about what Git is. We learned about version control. Now we're learning about what Git is. So it's a distributed version control system for tracking changes in source code during software development. So Distributed, what does distributed mean? It means not centralized. It means in different places. It means separated. Okay, that's what distributed means. And it's a distributed system for tracking changes to the source code. We talk about source code being the machine readable code that we are going to be writing, or that whoever is going to be writing. The reason why we need this is because it's designed for coordinating work amongst programmers. So more than one programmer doing different things in different places. That's the distributed nature of this thing. Everyone's not in the same place working on the same piece of code. They want to be able to work on it separately in their own spaces. But it can be used to track changes in any set of files. So it doesn't just need to be code. We're using the word source code because that is what we are, you know, that's the main thing that we are using this for. But it's not just source code. It doesn't have to be code. It can be any set of files that you care about. It can be used to track those changes. Its goals include speed, data integrity, and support for distributed non-linear workflows. You saw that word distributed in here twice. It was really hearken to, I don't even know if that's a word, 3 times in here, but it distributed, people in different places working on the same thing. That is the goal of this. How do you track changes to something that is separated? Okay, if it's not all in one place, how do you track changes? When we just looked at the Google Docs, the Google Slides that we were just looking at, that is a stored in a centralized place. There's one copy of that thing, and if I make changes, it'll show those changes, and someone else can come overwrite my changes, and someone else can make changes to another slide if we all had access to it. That's great, but that is not a distributed model. We are working on that in a centralized manner. We are all contributing to the same document. When you are doing software, when you are developing software, that is not what happens, and that's not what you want to do. You are all not editing a centralized code based. You want to be able to do it distributed, and we're going to make more sense of that in a second. So, 1, what does that mean? There is no central version of the code base. Each user has a working copy and full change history. Now, it's going to seem like, in a little bit, it's going to seem like I am going to contradict this first line. As we learn a little bit more today, it's going to seem like I contradict the first line where it says there is no central version of the code base. This is both true and false kind of at the same time, but there is no centralized version that we're all working off of. Every single person, every single thing that has access to the code base utilizing Git, utilizing this technology, has a working copy of it and the complete history of this thing. All right, so complete copies everywhere we go. The files, the folders, and the entire history of it. Everybody has it, okay? It tracks changes to a code base and exchanges patches when code bases need to be synchronized. So if you have the full history of code and I have the full history of code and Sally has the full history of code and we're making changes to our code, how do we make sure that other people who are working on essentially the same code base can get the changes that we want to make and add into it? And that's by creating Git, the system allows it to create patches with the changes that are necessary, and it allows you to exchange those patches with other people and for those patches to get their code base right in line with your code base and the changes that you made to your code base, okay? Again, this will all start making a little more sense as we start getting hands-on with it, but that is what's happening. This is what's happening when we are talking about Git and we're accepting these changes and making these changes to our source code. We are exchanging patches so that other people can get synchronized to the changes that we made. All right, a little bit more about Git. And before we do that, let me see where our installation is over here. It logged me out of the installer. What is this right here? Hold on, just for anyone who joined a little bit later, we are, I found a brand new, oh, maybe it's done. A brand new Linux distribution that I've never used before that looked kind of cool. I found it like 10 minutes before we started, and I wanted to see if I could install it really quick because it looks pretty cool. We're just, let me just check this real quick. I might need to remove the VirtualBox thing real quick. I do want to get it installed because it looks pretty cool. It looks really cool. Give me 1 second. Where is storage? Let's go ahead and remove that. Start it up and let's see if that starts up. Okay. A little bit more about Git, and the reason why this prompted me to go check the Linux installation was because this was the Git technology is actually is relatively new. So 2005, yeah, it's a surprisingly long time ago at this point, but in the world of technology, for how important Git is, this is not that long ago. 2005, I was 15 in 2005, and it wasn't 15 years ago, a little 16 years ago now, I guess. It's not that long ago. But it was created by a guy named Linus Torvalds. This is the same person who created the Linux kernel. He has created, arguably, and not even that arguably, the two most important pieces of technology to software development, period, the Linux kernel and Git itself. And Git was actually created for the development of the Linux kernel. Linux is free and open source, meaning many people, across the world contribute to it. And so when you're working on a big software project like this, it was difficult for people to, the workflow was very difficult for people to pass their code in and to be able to contribute their code to this project. And so he created Git to handle this process. He is giving people the finger. He's a very interesting guy, but he developed the Linux kernel, and that is what prompted me to go and check our installation over here to see if it's something that's even working. And again, Linux is, if you were unsure about how important Linux is, Linux now ships inside of Windows. They now ship a customized Linux kernel with Windows because Linux is that important. So it is something you should learn, and we'll be learning about that starting Thursday. We'll be diving into it. All right. Now, we talked about Git, the technology. So take a step back really quick. Git is a version control technology. You might hear it called an SCM, a source control management software. Source control, version control, very similar things. Right now, you can use them synonymously. Don't worry about it. There are some tiny differences between them, but for all intents and purposes right now, you can think about them as the same thing. If you ever see either one of those, source control versus version control, you can think about them being the exact same thing. The technology itself is the thing that allows us to work in a distributed manner, to be able to track the changes to source code or to a code repository. The way that it tracks these changes is when changes are made, we can pass back and forth patches. It creates patch files that tells the code base how to get from the previous version to the version that you're currently on, and you exchange those patches with other people to synchronize the code bases. That is essentially how it works. Now we're gonna dive deeper down the rabbit hole. Love the GitHub CLI. I agree. We are going to be, we're definitely going to be diving into the GitHub CLI a little bit during this course as well, because it is phenomenal. It is excellent. And I'm actually surprised it took GitHub so long to implement it, but it's dope. So Linux is legit since Microsoft ships it now. I mean, it was already super legit, but yeah, I mean, it was a big statement once they decided to do, the Windows subsystem for Linux, and it was a big deal. It's definitely a big deal. It's super legit now. It was super legit, but now it's like extra mega super legit because, Windows, I guess. Kind of weird to say. What's up, Josh? Welcome to the channel. Vitro, thank you so much for the follow as well. All right, Git repositories. We haven't dove into the terminology that we're gonna talk about tonight yet, but Git repositories is one of them, and let's talk about what they are. Our code needs a home. Git repositories store metadata. What is metadata? All metadata is it is bits of data that describe or information about the data. Okay, so it's data about data, really, and so it stores metadata for a set of files and or directories. So it tracks information about a set of files or directories. And that is what a repository is. It's just that set of files and directories that make up your code base. It stores the set of files. It it stores the set of files as well as a history of changes made to those files. All right, that is what a repository does. The repository is the holding place for our code base. And not only does it keep those files that are part of the code base, it keeps metadata about them, and it keeps the changes that have been made to them. The history is saved in that repository. Git needs this space. All right, it needs a repository, it needs a holding place that includes information about all the changes that have been made. Okay, so we use the word distributed, and so if it's not on my computer, how can others get this thing? Get it, not get it. Okay, well, if we're talking about being a distributed version control platform or source control management platform, the easy way for this to happen is through something called Git hosted Git repositories. And now you might, I've seen this be very confusing, and I understand why. Repository host, and this should be just repository hosts. All right, so a Git repository is simply a directory that has files and other folders in it that are your code base, and the history of that code base, of those files and those folders. A repository host is a platform that hosts these repositories. So you take these repositories and you need to put them somewhere that is centralized. This is what we're talking about, the thing that kind of contradicts, or feels like it contradicts, that earlier statement that says there's no centralized place for the code. This is true, but as far as the version control goes and Git is concerned, there's no centralized place, but a repository host allows you to be able to put your repositories in a centralized location so that multiple people can get them. So rather than you having to transmit changes to different people individually, or transmit or grab changes from each individual person who's making changes, you all can sync up to a common place. And maybe we should use the word common instead of centralized here, which is, there's some nuance there, but a common place. And so here are some of the biggest repository hosts. It's the next slide, but let's go to this next slide and we'll talk about it again here. But notice here that we're talking about repository hosts. These things are not the same thing as Git. So Git is the technology that allows for this version control. GitHub is not equal to Git. GitLab is not equal to Git. Bitbucket is not equal to Git. So people will say GitHub all the time and think that GitHub is either the maker of Git or the people who created Git and created this tooling. No, Git is the tool. All right, and these repository hosts, these are platforms for you to be able to save your repositories to if you need to. Okay, so the first one over here on the left is GitHub. This is the biggest one, has the largest market share, but it was acquired by Microsoft, I think in 2017, 2016, I don't really remember when, before a massive amount of money. And everyone thought they were gonna do a bunch of bad things. That's debatable if they have or not, but they've definitely done some good things. Whether or not they've done bad things, up to you, but they've done some great things. And so far, it's been a good acquisition. It's been a benefit. I think it's been a beneficial acquisition. It has, like I said, by far the largest market share. This is where everyone goes kind of by default. It offers unlimited free public repositories. So a repository, again, is just that, imagine a folder that has all of your code base in it and its history. So every time you have a new code base, you can create a new repository. You can put your repository on GitHub. You can have unlimited ones, but they're for free. You can have unlimited for free, but they need to be public. That means anybody can access them. That's what public means here. Anyone can access them. If you put it on GitHub and it's public, anyone can find it. Not only can anyone find it, anyone can retrieve that code and modify it and do what they want to it. Now they can't, they may not be able to, they can't change the code that you created without your permission, but they can do it themselves and save it to their own repository later. But you get you get unlimited private repositories as well. So ones that are hidden from everyone else, but they're limited to 3 contributors, okay? Or 3 collaborators, whatever. That just means that only 3 people can contribute to this repository. If you need more than 3 people to contribute, you know, now you have a team working on this thing, then you do have to pay. You do have to pay for GitHub services to be able to do that. And I think it's like $7 a month or something like that. Can't remember the last price, but we can look at it in a second. GitLab is another large one. A lot of people, GitLab gained, it's been around for a long time, first off, but it gained significant notoriety when Microsoft acquired GitHub. Why? Because Microsoft, the perception of Microsoft is that they were evil. And so people left GitHub in droves and went to GitLab. And maybe not droves, but a lot, I mean, people, there were a lot of people were moving over to something else. And GitLab was a choice for a lot of people. I don't think that GitHub and so they are competing products. I personally don't consider them to me, they solve different problems. Yes, they're competitors, but to me, they solve different problems. And I use both of these platforms. To me, these are 2 different tools used for different things, even though they have overlapping features and can be used for many of the same things. But GitLab is more than just source control management. It does do that. It does the same thing. It has all the features of Git. It has many of the features of GitHub, if not all of the features of GitHub, but it's more than just that. It is an entire platform as a service, really. It has project planning. GitHub has this as well now, but it has project planning. It has CI/CD pipelining. We talked about continuous integration and continuous delivery in the pipelines course. It allows for native pipelining. That's part of the tool itself. This was their big pull right up front. They call themselves like an entire DevOps pipeline kind of tool. They have monitoring and metrics and, you know, all of that observability. So it's one tool to do your complete pipelining. And they have unlimited public and unlimited private repositories. So I would check them out if I were you. Again, they do solve 2 different problems. I think I use them for different things. They are both great tools. GitHub, like I said, has the most market share. So it's important that you do have a GitHub. That's what we're going to be using throughout this course. But GitLab is pretty darn dope as well. Bitbucket, on the other hand, oh yeah, Execute, yes, their CI it's fabulous. It is. That's the perfect word there. It's pretty impressive, to be honest. GitHub now has CI with GitHub Actions. Not as, to me, I don't love GitHub Actions. It works. I don't love it. I prefer GitLab CI. I prefer other CI tools, but yeah, it has a lot. There's a lot to know in here. Also, GitLab is not only a cloud platform. So GitHub is only a cloud platform. You sign into GitHub, you pay them for their services. You can host GitLab for free. It is an open source software. You can take GitLab and you can actually host it on your own systems for free. The management of it can be pretty intense, but you can install it internally on your own system. So a lot of people in the cleared space use GitLab because of that, and because it's got all the pipelining features. A lot of organizations have their own GitLab instances set up as well, because you can have that granular control over all the stuff. So it's pretty dope. One day we started to do it. We were gonna try to get GitLab set up using Kubernetes, but it is pretty dope. D Bills, what's up, man? Welcome. Come on in, man. Just, you know, start to hear the words, start to gather all of the knowledge. It's good to see you, man. Thank you so much for the follow. So the last one over here on the right, this is not me saying the last one doesn't mean that these are the only ones, but Bitbucket. This is it's an Atlassian product. And one of the reasons why I throw this on here is because many of you have used other Atlassian tools. Even if you're not in tech, even if you're just getting into tech, you probably use an Atlassian product in your lifetime. This is Trello. Trello is an Atlassian product, but you probably have used Jira or Confluence or a bunch of other ones. But Bitbucket is Atlassian's source control management tool, which means it has great integration with other Atlassian products. All right, so that's the pull here. It's the ecosystem. It's like Apple. You know, as much as I hate Jira, I will say that right now. I hate Jira. I do not think there's a better tool out for what Jira does. I don't think there's a better tool out. You can say Trello. I don't think you can equate them at all. Trello to me, again, I think it solves a different subset of problems. To be honest, there's some overlap, but Trello's Confluence as well. I despise Confluence. I don't think there's many better tools than Confluence as well. But I think Confluence is terrible, but there's nothing better for what it does. So I guess that makes it good. So, you know, for organizations who are using these Atlassian products, Bitbucket may be a great option for these things due to its integration. It also has built-in CI, which is helpful. CI, again, being continuous integration. This allows for you to have automatic pipelines for your code. So when code changes are made, automatic things can happen, like the building of the code for deployment, or you know, you can set off these automated pipelines to do all kinds of things if you need them. So Bitbucket is great for that. Yeah, there are other repository hosts. These are just some of them, but these are probably the biggest. There's like, I'm trying to think of, there's one other relatively large one, but it's escaping me right now. But not a huge deal for you to know them. But you do need to know that Git and these platforms are not the same thing. They are different. All right, Git is the technology. All these other things are, these repository hosts is a place to host the repositories that you have created and that you are managing via Git. All right, Git is free and open source. You don't got to pay for it. It's its own tool. These platforms are taking what is created by that tool and just giving you a place to really to store them. For right now, that's kind of how what you think about it, a place to store them. They do give you a lot more functionality than that, but essentially that's what they are. All right, so what do we cover? We've really covered all of the we've covered the main concepts. All right. Right now, Git just a tool that allows us to track changes to a code base. It does that by creating patches for when things are, whenever modifications are made, and then you exchange those patches with other people who are using Git who want to synchronize with your code. We learned about these repository hosting platforms like GitHub, GitLab, Bitbucket, where we can take the repositories that we've created with Git, those repositories simply being files and folders and their complete history and metadata about those files and folders. And we can save those things to these repository hosting platforms like GitHub, which gives us common ground to be able to exchange patches quickly and easily. All right. Right now it might seem kind of weird. It's going to seem like when we hop into GitHub, because of the workflow that we're going to learn, it's going to make it seem like GitHub or GitLab, these places are the source of, well, not source of truth, but they are the centralized place. Again, it's worth noting that these platforms are just using Git the same way you're using Git on your computer. And what do we say about Git? We said that it's distributed and that every person who has access to the code not only has all of the files and folders, but has the full history as well. So even though we are using this common place to exchange patches, GitHub is just another person who has access to the code. It'll be just like if you grabbed it, anyone's computer. I can make my computer the hosting platform for you. We're gonna learn about the word remote in a little bit. We're gonna learn about remotes shortly, but anyone's computer could be exactly what GitHub or GitLab or Bitbucket or any of these things are. You would be able to provide all of the same features, but you'd be able to do everything that Git needs to do, just be in a tougher way. But yeah. Jira is a monster. Yes, Jira is a monster. That is why I don't, if I don't have to use it, I won't use it, but Jira is a monster. What's up, Aya? It is good to see you. SourceForge may be the other one you were thinking about. I don't think, I didn't even know SourceForge was is SourceForge version control? There are other ones. So there are other platforms that don't use Git. There's other tooling for source control and version control. There's Mercurial, there's SVN, there's a bunch of other ones that manage these files differently. They manage the history differently. Git has become the most popular. It really is really good. It's super powerful. And it's pretty dope. Managed Chaos, what's up, man? It's good to see you. I appreciate you coming through. Thank you so much for the Twitch Prime sub. I really appreciate it. And again, I'm open to that conversation, man. For sure. Sorry, I just been, there's been a lot going on, but I'm definitely good. When are we doing DevOps again? So the 2 weeks, We start level 2 of all the courses. Not 2 weeks, 3 weeks. April 5th. April 5th begins all of the new boot camps. So yeah, keep an eye out for that. Information will be coming out about that shortly. I'll do my little announcements very soon because I need people to, you know, spread the word so that you all can have a good time. So what we doing? We're actually not, because of the baby situation. We're actually not going to start the web development one yet. Unfortunately, it will still be the same 3. Horizons will actually move though. Horizons will not be the Friday course anymore. Horizons will get a prime time spot. Horizons will probably take the place of Decoded. Decoded will likely get a single day spot, just so you know. Unfortunately, but both fortunately and unfortunately. The DevOps stuff we need the most time for. We need 2 days a week for pipelines. Like we have to have it. And so because the cloud computing stuff only got 1 day a week, they're now going to get 2 days a week. So they'll probably be on the Tuesday and Thursday slot, and the other one will be Friday. And we may even remove the build series. We'll see how it works. We may even need to remove the build series on Saturday and have Decoded be Friday and Saturday. But we'll figure that out. We'll definitely figure that out. I'll let you know very soon. That's the only reason I haven't released the information. I'm trying to like gauge the timing and make it work. All right, so let's keep moving. What time is it? 7:43. We're good to go. So installation. All right, Git is just a tool. Let's get it installed. If you want to get it installed, you can go to git-scm.com/downloads. You may be able to do !git. I feel like that's something I would have set up. That's something I did not set up. But yeah, you can click on that. git-scm.com/downloads will allow you to download it. Now, before you go ahead and download it, let me tell you, if you're on a Mac, you might have it installed already. Not 100% sure. Why Garuda? Hold on. Why is it trying to log me in as Garuda when I want to log in as my user that I created? All right, no big deal. We just won't use it right now. But if you're on Mac, it's probably already installed. If it is not installed, you can do it via Brew. So if you're using Homebrew, you can do Brew install Git. If not, feel free to click the Mac OS installer and install it. All good, no big deal there. All right. Windows in particular, you're the people who need to know this the most. If you're on Linux, you can install it via this, or you can use your package managers if you're using Yum or apt, but it's also probably installed on your machine. It's probably already there, most likely. Windows, on the other hand, this is where it gets tricky. If you are not using the Windows subsystem for Linux, then when you download this, it's going to give you some extra options. So it's going to install Git natively in Windows, and you'll be able to access it through your command prompt. So using the command prompt or PowerShell, you'll be able to access it via either one. It will likely give you an installation. Let me actually click through it, because it's probably going to also give you installation options for you to set up something called Migwin or Sigwin. I can't remember which one they have you install, but it installs like a little virtual kernel as well. And it's just like a little mini Linux installation that allows you to do all of your Git stuff through it. That's not really necessary anymore, but it will give you those things. You know, if you want it, it's fine. It doesn't hurt the computer. But just, you know, if you are, it's going to give you a bunch of extra stuff if you don't know what you're looking at. So you just go through the installer, and here it is. So it'll give you Git Bash and the Git GUI. I actually say leave it all there. I actually say install all of the defaults. Just let it go. Yeah, let me go back and see this. Yeah, make sure this just do all the recommended stuff if you're on Windows, and you should be fine. I hope. I don't use Git on Windows, but you should be able to use it just fine. Yeah, Sigwin was, you know, it used to be what you had to use, and it was good. It's definitely the OG for sure. So pretty easy to install. Like I said, the way that you know if you have it, this is a command line tool by default. So if you're not sure if you have it, if you're on Linux, open up your terminal. So you on Mac, if you hit if you hold command and hit spacebar and you type in terminal, it'll open up something that looks like this. And all you gotta do is type in Git. If you type in Git and you get anything, so Git being Git, if you get anything other than command not found, then you're probably good to go. It's probably installed. If you get something that looks like this, a bunch of output, you're good to go. It is installed and you're ready to go. So this is actually what I just installed on Windows. Yeah, but whatever you're using. So if you're on Windows, I just use the Windows terminal, but again, use command prompt or PowerShell to be able to do that. After you get it installed. Anyone using Linux, use your terminal of choice. Again, I assume if you're using Linux, you probably know what a terminal is at least. And so just open up that tool, whatever tool you're using for it, and type in Git. Make sure you have it installed. Most part, yeah, it should be fine. I like to change the endings. Oh, the default endings, yeah. Yeah, you can do it with the Git Config too. Yep. Okay, so once you have it installed, you're mostly ready to go. There are some things that we are going to do in a second to get it more set up, but the goal right now is simply to get it installed. That's the only goal, because we're going to learn about GitHub first, and then we are going to dive into all of it at the same time and have a little fun. Yep, if you're using Linux, what's up, Stone Cold Coder? You can do apt-get install git if you are on a Debian-based distribution. If you are not, if you're on something that's Red Hat based, you must use yum or DNF or something like that. Hold on, not listed, username. Let me see, maybe I just had to do it like this. No. Huh, I don't know, this installation is super weird. It's not giving me the user that was created, and it's also not allowing, whatever, doesn't really matter. Doesn't matter at all. So what I'm gonna do for this though, I'm actually going to, if you're having trouble period with your machine or whatever, I'm actually gonna go into Linode, and I'm actually gonna spin up a brand new system for this. If you want some free credits to be able to do this completely free, you can choose the panel down below. It'll give you $100 worth of free credits. I use Linode purely for separation of all the things that I do, and so I have a common place for me to log in to make some changes. But I'm gonna create a brand new server here, just so that I'm starting fresh with Git, because I already have Git set up everywhere else. I don't want to unset it up. Okay, I don't want to remove all my credentials and stuff. So I'm gonna do this on a completely fresh environment, just so you can see it from scratch. So I'm gonna do this on an Ubuntu server as usual. So if you're good locally, you don't need to do any of this. This is just something I'm doing. 20.04 region. Hold on one second. Okay. I'm just gonna choose the smallest one, the $5 a month one, because that's all I need right here. And I'll call this one tracks, because that's what we're doing here. Let me give it a password here. Don't need anything extra, and I'll create this. Yum install Git on Amazon Linux. Yeah, yep. Maybe actually. I feel like Amazon Linux is always weird because some of the stuff's already in the repositories and has a weird enable command. C-Bear, so did I go to, that's a good question. Did you go to college to learn the code? Yes and no. I did go to college. I went to University of Maryland, Baltimore County. I went wanting to be a mechanical engineer first. And then I realized it wasn't what I thought it was going to be. And I moved to software engineering, and I stayed in software engineering for 1 semester. I did 1 semester of computer science. And I went through the weed out courses, and I got weeded out, plain and simple. So I switched to, what did I switch to? Information systems. I switched to information systems, and I did that, which was, gonna be honest with you, I was already fairly well versed in computers. I was not a coder before that, but I knew a fair amount about computer hardware, and like I could get, I had learned enough about computers by breaking them and by infecting them with all kinds of malware and all kinds of bad things, because I was downloading things I shouldn't have been downloading, going to sites I shouldn't have been going to. So I knew how to use a computer pretty well, but I never finished school. I do not have a degree. I went to school for 5 years, and I'm very close to a degree. I'm only like 7 credits short, 7 or 9 credits short. And I started working. I got a job in the industry, started working, and you always say you're gonna go back and finish, and 10 years later, I didn't go back and finish. So I don't think that it's been a hindrance to me at all. But that everyone's path is different though. Definitely. I don't think that I let those 5 years go to waste. To be honest, I've been able to utilize some of those connections, people I met and things to further my career. I've been able to build a community there. For my business now, I work with people from UMBC right now. So it is what it is. What did you do to land a job in development? I started out in systems. I started out being a Linux administrator, and I just learned. I kind of just dove into it, and I realized, I started to see the patterns of the industry. I started to see what people needed to know. I started to realize that people don't care about it quite as much. I will say that software is a little bit different. Going straight into software is a little different than ops roles, to be honest. But let's be clear, you do not need a degree. You don't need a degree to get in to do any of this stuff. You don't need it. I work with tons of people who don't have one. But a degree is a tool. A degree is a tool just like anything else, which can be beneficial to you, the industry. 100%. It can be beneficial. It's a tool that can help you do things. Just like, kind of like certifications. Certifications can help, but they're not the end all be all. Because you have a degree in computer science, does not mean you're going to be able to get a role in software or in development or whatever you want to do. Once you get the first one is the hardest. Once you get the first one, it is much easier to navigate the industry. People, for some reason, companies don't want to be the first to take a chance on you, but they're very willing after that. Very soon after, they're willing to take you with just one job on the resume. But then it snowballs. It definitely snowballs. I do think for some people, a degree is the way. I would say though, just to be wary, I don't think there's anything wrong with getting a degree. I just don't go into debt. Don't go into significant debt to get a degree, because I don't think it's that valuable. But I do think the college experience is something that, if you can experience it, do it. But again, it's not worth getting into debt over, to be honest. I was fortunate enough to go to school on a scholarship, track and field scholarship, which was super helpful. Didn't help me pass. Tell you that right now. Did not help me pass everything. I had a tough time. I'm not gonna lie. And it's just more so time than anything. I got weeded out of computer science, not because I couldn't make stuff work, because I would spend tons of time building something and it would work and I would still get a D. That's what was wild. That's what weeded me out. That is why it was supposed to be a weed out course. They told us it was a weed out course. I would do the thing. I would spend the hours. The code would run and I would still get a D, and that was pretty trash. I didn't get any certs till I was well into my career. I didn't get any certs until I was 6 years into my career, at least. And I ended up getting some cloud certs. Certs are good. Again, certs are tools. Certs are tools. Focus, if you can, put your energy, use certs as a tool to get roles, but also use certs as a tool to be able to dive deeper into something that you are actively trying to learn. Don't feel like a cert is going to, if I pass this Docker cert, if I pass this cloud cert, if I pass whatever cert it is, I now know the thing. No, you don't. You don't know the thing. It can be helpful. It can be helpful using that material in pursuit of the thing that you're trying to learn. And again, it can add some credibility to you as well. But learn the thing. Focus on learning the thing more so. And that's harder, that's easier said than done. One day we're gonna talk about that more in depth. We're not, or maybe at the end of today, we could talk about that a little bit more in depth as well. I'm looking to get into software. I don't think there's anything wrong with software boot camps at all. I think that make sure the one that you decide to go with makes sense for you. Okay, they can be expensive as well. They can be very expensive, and they cannot be worth it. So just be wary. Do your research. Talk to a lot of people. Also, I think that people think, oh, if I go through this thing, I'm going to get a job. Make sure that when you're going into the boot camp, that you're ready to put in all the work. Like, make sure you're still ready to put it, even though they're guiding you through the things, make sure you have committed to doing the things that you need to do, not just coast through it, because getting into tech is hard. But I'm telling you, once you're in it, it's love. You'll have your hard days and stuff, but you can move how you want. Once you've picked up the skills, there's so few people who have these skills that it's so easy to then make your own path. You can make your own destiny at any given time. The first role's the hardest. After you get the first one, it's cake, honestly. Like, it's cake. Doesn't mean you'll get any job you want. Let me be clear about that. I've done hundreds of interviews and I've not gotten many roles that I wanted, but I learned through the process what were the reasons why I didn't get it, and what were the reasons why I wasn't ready for it, or and I was able to apply those things back to my own learning or to the way that I interviewed, and it helped me out a lot. So yeah. Pricing and placement, I love it. That's tangible information right there. Managed chaos, pricing and placement, I agree. Appreciate that, thank you. But I self-studied. Yeah, I self-studied. I'm not joking. I was doing operations work, pure operation systems, web operations. I was a systems guy, hands-on server. And then once I saw the industry was moving along and I was trying to get new roles and I wasn't getting the higher paying roles because I didn't have any of the automation, I didn't know any coding. I was fortunate enough to have a work from home job, a fully remote job years ago. I was tired of being in the house. I would literally leave the house, I'll go work out, and then we'll go to Starbucks. I would sit in Starbucks, and I would watch something on Netflix for like 20 minutes, and then I would go on Linux Academy or something for the rest of the night. And I would just, at my own pace, I would go through and learn Puppet or something like that. And I would just go through it. And I by no means was I good at these things, but I learned what they did. I learned what problems they solved, and I was able to talk through them, like talk to people through an interview. And it is what it is. You'd be surprised at how little people know. You think everyone knows all this stuff. They do not. Most people don't know. There's so many different tools. There's so many different concepts to learn. A lot of people are pretty lost on these things. So I can, it's don't think you got to know everything. It can get pretty confusing. What's up, Gadudas? All right, let me keep going. Let's actually get hands on. We have plenty of time though. Every time we say that we shoot ourselves in the foot, tonight we're not shooting ourselves in the foot. We have plenty of time. Okay, so what we're gonna do now is I'm gonna get logged into this server. I'm gonna get installed. So let me just get logged in. All right, my website. So there's two websites. The one for this is academy.mastermind.io. That is for the academy. That's what this is. It'll be free always. But the rest of the business I do run. So this started first, actually, for people who are new. Academy.mastermind.io. The academy started out as a kind of just something I enjoyed doing while I still had a full-time job. I've actually since gone through a whole business incubator. Never wanted to start a business in my life, and now I run my own business called Mastermind. There's a lot more to it than this, but this is the thing that I love the most. This started first. The business came after the academy, to be honest, and we have a little fun here. But academy.mastermind.io, if you want to find more information about what we do here, that's where you can find it. All right, so let's see. Now I'm into a brand new server, a brand new system. I hate it because I don't have all my cool stuff here. And if I type in Git is already installed on my system. That's really cool. But if it wasn't, I could have done an apt install Git, but it's not that. And it would have installed it for me, which is great. So now that we have Git installed, make sure you're there. Let's go take a look at GitHub. So head over to github.com. Feel free to sign up on github.com. Yours won't look like this. I'll sign out really quick and it'll look like this. If you do not have a GitHub account, take your time to sign up right now. It's just like any other website. We'll take a few minutes to let you get all signed up. Once you get inside, you will be presented with a screen like this. You will not have as much stuff on here because you have a brand new account. You're not following anyone. You don't have any repositories, but take a few minutes. I'll let you get signed up on GitHub, and we can talk. We can go through GitHub and see what it looks like and get a feel for what it is. CC, I went through a digital services incubator. So digital services are technical services done for the government. I went through one called Hutch. Was it? It's Hutch Studio. And so this is primarily centered around providing digital services for the government. So software development things for the government. How do you do it properly? And how do we change the government? Not just how do we get contracts? How do we change the way that the government does tech? And so, look at me. I was a part of the very first cohort of this. I am actually the only company who right now does not provide any government services. I'm the only one. I'm a special use case, but I do support the other companies that are a part of this as well. But my specialties do lie in the systems, DevOps, automation space. And so I'm set up to provide those services. So I have everything that I need to be able to provide digital services to the government. If I decide to, that is on the roadmap for things to do. That's definitely on the roadmap for things to do. When we're talking about how do you get as many people into the industry as possible, how do you scale opportunity? Part of the way to scale opportunity is to do work for people. And so there will be an arm of the organization later down the line that where we are taking on government contracts, and we're allowing people to learn by doing, and to if we can figure it out. There's weird contracting vehicles and stuff you're trying to figure out. It's weird trying to figure out how to make it work properly because there's some pretty specific things that have to go into government contracts when you're hiring for government contracts. So there's a lot of red tape to play around, but we're gonna figure it out. We're definitely gonna figure it out for sure. But if anyone's ever been interested in doing something like that, this is where you can go to learn a ton and get amazing help and resources for this. I participated in it for 2 years, and I'm not joking. It was amazing, really was. Ashley? Okay. Wait, I'm trying to get my guy Mastermind. Maybe we could. Oh, what's up? My bad. My bad. First off, it's good to see you. Oh, first off, I see you got a transport company. Almighty Installs, Almighty Transport. So do you mean like a transport, like a trucking company? What do you mean by transport? Also, what about Almighty Installs? I like this. Started from the mud. I love it. Oh, delivery service. That's dope. A delivery service that augments like other delivery services? Or is it here? People coming from all over. Contractor for Home Depot. That's dope. That's awesome. I'm not gonna lie. I dabbled the idea of getting into logistics after I found out. I watched this long video about getting into the logistics business. No experience, absolutely zero experience, but it seemed pretty lucrative, and I was like, I'm gonna do that one day. And I really thought about it, but I never. I'm glad I did it. I'm definitely glad I didn't. In Oklahoma City, that's dope. That's pretty cool. That's really cool. It started in 2012, so you've been working it for a while. That's awesome. I'm relatively new to the business world. We were formed in 2019, so zero info on dishwashers until 08. Yeah, that's great. That's how it is. I don't know. I'll say that after going through this program, I have no idea how people successfully begin businesses without the information that I've received. I really feel I'm proud. I'm in awe of everyone who is running a successful business without the help that I've gotten. I never could have done it. I would have failed in 2 minutes. Okay, so now that I've given you a few minutes to get set up with your account, you should be good. You should be logged in. Let's take a look around. Up top, you see a little search bar. Up here, that's so you can search the entirety of GitHub or only your stuff on GitHub. It's up to you. We're gonna learn about pull requests. We're gonna learn about all these things up top. Don't sweat that. Explore will allow you to get to see the things that are going on GitHub, find other people's code, learn about news and stuff. It's helpful, but you probably won't go to this page very often, to be honest. What you might want to go to is, you can go to your profile and see some information about your profile. This might be the screen that it dropped you on, honestly, but you won't have any repositories. It probably says you have no repositories. It gives you an overview page here of a couple of repositories. You can see here, I have 56 repositories on this account. Projects and packages. Repositories, these are all different these are different pieces of software. They're different code bases. All right, so they're all here and I can go into them. And now, again, if they're repositories, what can I see? I can see everything that's in there, all the files, and I can also see the entire history of it as well. Conflux Chiller, the Hutch link is hutchstudio.io. Share here. Another thing that's good about this is a lot of these companies, I think we're through 3 cohorts now. They all do contracts with the government. They build software, they do DevOps, they do these things. And so these are companies who need you all. So as they get job openings and stuff, we'll put them on here. We'll be connecting you with these, not just these companies, but these CEOs, and helping you all get roles in their companies as well. All right, so this is a repository right here. This is what it looks like. This is a code base. There are folders here and there are files here, and we can actually see the full history. I'm gonna click on this button right here. You don't need to go through and click this at all because you probably can't see anything like this, but this is actually the full history of this entire code base. There's not much here. I haven't touched this in a long time. Even though I said I touched it 5 days ago, I don't know why I said that. Maybe someone else. Oh, okay, an automated tool, Dependabot did it. But this is what a repository is, simply the files and their history, okay? Super nice, but if you go back to your profile, you can see these things. The thing that you see right here is just a little heat map on how much code you've contributed to GitHub. So the green is, days you've pushed code, and the darker green it is how, you've pushed a lot of code on these days. So that's helpful. People really like to get their little map. I forgot what it's called. They like to get it, nice and full. Just to, companies. There are companies who look at this. I don't know why. I don't look at this at all. It is not a good indication of how much code someone is writing. I don't think. I don't think. Me personally, as someone who did not start their career in software, I think it is a bad judge of how much work you've done. Yeah, it's a heat map. It can be a good indicator, but the lack of it can be not meaningful at all. It doesn't tell you anything. I don't think it tells you much. So, and like I see my contribution over the years to this account, I'm surprised. So this is not my main account. This is my mastermind account for this. I do have another account, which I should have much more contribution on, but yeah. So you might see that there. You can see some organizations. These are different, entities that you may belong to, that you can contribute code to, that you may be a part of. But that's what's listed here. So what you need to know is that if you want to create a new repository, you can do so by right-clicking this. Click this button over here, left-clicking it, head over to the Your Repository section. So right here, and this green button over here, green is going to be the color that's going to draw your eyes to different things inside of GitHub. And we're going to be able to create a brand new repository from here. What's up, Yan? Welcome to the channel. Dr. Feynman, welcome to the channel as well. ZRE, welcome. It's good to have you. All right, let's go back to our slides real quick. We got this stuff installed. Let's talk about some terminology. We dove into GitHub just a little bit. It's a website. I think that you're likely familiar with how to get around the website. Click around, get comfortable. It's okay. You're not going to break anything. Seriously, click around, get familiar with it. I wanted you to be able, before we did the next piece, after the Git terminology, I wanted you to already have your account set up so that we could go and create our own repository. That's the only thing you need to have done right now. But one day, not one day, but after we're done here, explore. I always tell people, explore. Don't wait for someone to show you all the things. Go explore, click around, see what does what, see what options you have available to you. Definitely go through and do that. What's up, G-Bone? Welcome to the channel. It's good to see you. All right. Oh, first off, I forgot this had dark mode now, so I'm gonna switch it up to dark mode because, better for the eyes, maybe. So let's talk about some of the buzzwords, and then let's go ahead and make our first repository and talk about a Git workflow. So some Git terminology. Let's go through it. Object, I want you to be familiar with, but you don't necessarily need to remember this one. There's a lot of just words. There's no particular order to these words, so don't sweat it. Some of the definitions will have other terminology in them. So, we'll get through it. There are 3 slides of this, but you need to be familiar with the words. Object. Okay, this is the unit of storage in GitHub. The things that are stored in GitHub, they're objects, okay? They cannot be changed because they are uniquely identifiable. Don't worry about that piece. Just know that these objects are unique, and that is the method of storage, the unit of storage in Git. It saves things via objects. Pretty much everything is an object. That's okay. You'll see the only reason I even included this, I thought about whether or not to include object, is because you'll see the word object come up a lot in some of the output for some of the Git commands and stuff. Just know that that is the unit of storage. You might say, hey, 37 objects or whatever. This is just your unit of storage. In Git, you probably won't need to know much more than that. All right, now this is something that you absolutely need to know. A commit. This is both a verb and a noun. Okay, it can be it's both a verb and a noun. It's something that you do in Git, and it's a thing in Git, but it is a single point in the Git history. Okay, so it is a single point in the history of a repository. So for a piece of code, let's say we're tracking the changes in one file, and we've changed it 10 times. Each time we've changed it and we've saved it. Not save the file, but every time that we want to track some changes, every time we say, hey, we've made some changes to this file and we need to rewrite the history. We need to add this to the history of this file. We want to make this official. The way that we do that is we commit those changes. All right. So the verb is to make that new snapshot or that new single point in the history. And, whenever we refer to a commit, we're referring to a single point in the history. All right. Working tree. This is the tree of actual checked out files. This is, when you hear working tree, this is talking about the current set of files that you have available to you that you're working on. This will make more sense in just a few minutes, but working tree means the set of files that I have available to me right now, that I have checked out and available to me at this time. Because that indicates to you that there's files that you cannot have available to you at a current time. Master or main, these are 2 different things. You might hear master, you might hear main. You'll hear them both right now. Master used to be this thing, but it's the default branch. We're about to talk about branches in a second, but let's just say the default history. So when we're talking about the history of our code base, master was the default history. They've since switched. The industry is trying to move away from the word master and move to the word main. And so you'll see main some, you'll see master some. It's important to be familiar with both of them because it is not phased out yet, and you'll see them both. So these are the default branches of history, and you're gonna learn more about that in a second. Refs. You'll see refs a lot. I know you can be effective without fully understanding what ref is, but ref is a path that points to an object. Remember, what's an object? That's a unit of storage. So it's a path that points to a stored item or to another ref. So ref is short for reference. So it is just a path to, it's referring to something. It is a path to an object, so a stored item, or to another path of a stored item. I know that can be pretty confusing, but we'll just leave that there. Why the change from master to main? Simply because of the connotation of the word master. So there's a lot of places in tech where the master slave reference is used due to the relationship between two pieces of technology, and you know, it's something that we've now determined should be different because it is actually a pretty weird combination of things to do. So now you might have leader and follower. You might hear referred to that now, or main and backup or something. I forgot what the other terminology of it is, but just moving away from it, you know, to better word choices. So this is so ref is like, you know, if 10 is you need to know what this is, and 1 is like, nah, I want to know this. Ref's like in the middle. 5, you'll see it a lot. But, and some people might be getting mad at me for saying this, but it's not something that's going to make or break you. But just be familiar with it. It's not going to make or break you. Branch is a 10 though. Branch, you need to know. This is a 10. Must know. This is an active line of development. Okay. And so active line of development, it could be inactive as well, but active line of development. So a branch is a new path of history for a code base. So let's draw a little bit real quick so that you can understand a branch, and so we can talk about Git a little more deeply. So let's say everything starts on this day. Your code base starts here, and time, and this line right here is time. And so time isn't really a part, like this linear time thing is not really a part of Git. There's actually a pretty poor way of representing it, actually. But over time, you work on new things and you make the code base better. And so every time you want to save something, what's that called? A commit. So you commit a new point in history, and you keep going, and you go, and you know, you make some changes here, you do more today, and you do one here. Okay. This is that default. This is the main timeline. This is the main history branch for our code base. A branch is a active development line for the code base, but it has a different path. It has branches have different histories, or can have different histories. So maybe once we were right here, maybe we weren't sure what we want to do with the code, or maybe we wanted to begin working on a different version of the code base or something, and we wanted to diverge the path of history. And so we could branch off like a tree, and we could begin doing some development, same code base. These are the exact same code base, but now maybe this branch is called, we can call it whatever we want. Maybe it's called something like development. And this can have a completely different history. All right. And different things can be over here. So same code base, these two things can differ completely. All right. They might share, they're probably going to share a part of the code base. So, you know, in this instance, although it starts right here, that means it still has like the full history of the development branch includes all of this. All right. So different branches. So you could have many different branches. You could, you know, have a new branch up here. You could have even another branch off of here. You have different branches of the history of the code base. This is what makes Git so great, but also makes it so confusing. This is why you'll run into some issues. Okay. But it's just a different branch of development. It's a different lineage of the source code. Okay. Different history. All right, head. This is also like, this is not a 10, but it's like an 8.5. Okay, head. This is so head is not the current branch. Well, head is the current branch. Head is a reference as well. You'll see it. It's in all caps. We're gonna talk a little bit more deeply about head, and talking about head makes it be a grown up. Talking about this identifier head will make more sense once we have hands-on code in a second. It makes it easier. It makes it make a little bit more sense. You'll see it in all caps. It is referring to the current branch. All right. Checkout. Checkout is another word, very important. Probably a 9.5. It's a 10. I lied. Checkout's a 10. Change or update the working tree. So now we're referencing back to this working tree. These are the actual files that are checked out. So We learned about branches. We learned about those different histories of code. So maybe if we are working on the main branch, we have that code actively checked out when we're working on it. Because it's the same code base, if we want to work, if we would now like to work on the development branch, we have to check that code out. Okay, we have to make it our active working branch. We have to take that, we have to make those files available to us, because if we're on the main branch, because this is the same code base, those files are not accessible to us yet. We need to check those files out, work on those files, and if we need to, work on the main branch again, then we need to go check those files out again, kind of like the library. And so change or update the working tree, the files that you're currently working with or working on. Fetch. This is where things get confusing. A lot of people have been using Git for a long time and don't understand truly what fetch does. But fetch, it grabs the head reference. So the current branch references, well, not the current, it grabs branch references from the remote repo. We're about to talk about remote, but it gets all new objects that you need. So fetch, it's got the word objects in there. That objects, the little units of storage, okay? Fetch goes to, when we want to synchronize a repo, okay? We want to synchronize a repository. Fetch allows you to go and get those Delta files, those patch files. It allows you to get those patch files, bring it down, and get all of the objects that need to go with it. So sometimes if you're adding a brand new file to the code base, that's a new piece of storage. That's a new storage item. So we'll grab the patches and we'll grab those objects, okay? We'll grab those objects and we will bring them to our computer, okay? What fetch does not do, and this is something that is a miss by a lot of people, fetch does not make those things that you pulled. When you fetch stuff, it does not mean you are now working on it. It pulls it down and puts it in your repository, okay? It gets the information in there, it gets those objects in there, but it does not mean you are now working on that thing. It just means that it's now available and you have it all locally, but it does not check out those files, okay? It's going to make a little more sense again when we do it hands-on. It does not check out those things, and it does not it does not check out, it doesn't merge those files, and it grabs the objects, it grabs the patches, but it doesn't apply any of those things. It just gathers them up, okay? Remote is a common repo to sync to and from. GitHub is going to be our remote. Remote, is a place that you can set up to exchange patches with. I could set up your computer as my remote. If I knew your IP address and I was networked to it, I could use your computer as my remote. I could use GitLab as my remote. I could use Bitbucket as my remote. And this is a remote place to retrieve things from. The remote is per repo, okay? So you can have a different remote for every single one of your repos if you like. And you can also have multiple remotes for a repo, but yeah. Let's see. Fetch doesn't merge the code. Correct. Fetch is saying, hey, what's up? Yeah, it's saying, hey, give me all this. Let me know what's changed. Let me know what's changed. Let me go ahead and grab the information. Let me grab the objects that I'm going to need to make these changes, but I'm not going to do anything yet. I'm just getting ready to, I'm grabbing the information so that I know about it, but I'm not going to change anything on your local computer. I think fetch is getting files from point A. So yeah, and so fetch grabs things from whatever you have set up as the remote. And so again, in our case, the remotes are going to be GitHub. Merge. This is the scary word. This is a 10 on the list of things to know. Bring contents from another branch from another branch into the current one. And I simplified that a little too much, to be honest. It's not just that. That is not all the merge is. Merge is the merging of code, of changes. It's the merging of changes. When we've exchanged those patches, so fetch gets the patches and gets the objects that it needs. Merging is saying, hey, apply those patches. Go ahead and try to take the changes and merge them into the code that already exists. Not only can we do that through a fetch, we can do that between branches. So if I go back to what we had over here, and let's say we have this lineage here that starts here, and this is main, and changes are going down like this, and we got a change here, and a new branch called development goes off of here. It's called dev, and a change is made here, here, and here. We may want to, we often want to take the changes that we did over here and get them back into the default branch. And so we would merge them back in, okay? And so we would basically take all the changes that are here, and maybe there's a couple changes that happen in here, and we would smash them all together. Basically, we would do our best to combine them all. All right, we would try to apply those patches in a way to make sure our code is good. This is a scary thing. Merging can be complicated because you will have something called conflicts. All right, when you try to stick changes to two files, let's say I made a bunch of changes to a file, and then you made a bunch of changes to a file. If we change some of the same things, how do you combine those? Like, how does the computer know how to stick those things together? It doesn't always know how to stick those things together. And so you'll have these things called merge conflicts, but merging is simply, merging those files and those histories back together. All right, so pull, you'll use pull a lot. A lot of people don't know what fetch is because they know what pull is. A pull is a fetch plus a merge. So a pull will get those refs, it'll get those references, it'll get those objects that it needs, it'll get those patch files, and then it'll also merge it in to your current working directory, or not even to your current working directory, to whatever branch you pulled, to whatever you pulled against. It will fetch the information, and then it'll merge those changes in. Okay, so sometimes your pull will fail because the merge can't be done successfully. All right, so pull, now it fetches and it merges. Fetch you can do by itself, it just gets all the stuff but doesn't kind of combine it all. If you want to combine it all, you got to merge it in. So you can do them separately, or you can do them together. What's the point of fetch? When would I ever want to pull code and not merge? If you, I've only ever fetched and not merged when I just wanted to remember to get the updates that I needed, but I wasn't ready yet. I didn't have my code in a place where I could merge that stuff in. I didn't want to merge that stuff in. I didn't want to, I needed to make so that there wouldn't be any conflicts. I needed to make some changes and do some other things before I merged them in. That's the only time I've ever needed to do it. I'm sure there are other scenarios which make sense that I haven't run into yet. I think that's one of the, and again, that's one of the other big reasons why Git is such a tough thing to master, is because you use it, it can give you a bunch of tools to use based on random, like different scenarios that you might find yourself in. I have not found the need to do it unless if I want to see, get details for new branches on remote. If I want to see if there's anything new, I might do a fetch before I merge it in. I've done that before as well, but I can't really think of many other reasons why. Fetching an already established code. So, I mean, already established code, if you haven't made any changes, a pull does that just fine. But yeah, if someone has pushed some changes and you want to just grab the changes so that you can kind of have an understanding of what happened or know that something happened, you can fetch it first. But yeah, I'm sure there's some other good reasons why. All right, and the last thing here is push. Update remote head ref and push objects. So it says update remote head reference. So we talked about head being the current branch. It's not. I should have went back and I should have changed that, to be honest. But update the remote head ref and push objects. So the biggest thing with push is that makes the most sense up front is that it's going to push the objects to the remote. Okay, so push says, hey, I've made changes to the history of this code base. I would now like to share it to the common place. I would like to share it to the remote. So I want to take the history and the changes that I made, and I would like to push them to the remote. All right, so it's going to push those things up, and it's going to push those things up. Updating head is going to update some pointer references to the beginning of the branch, and it is the current branch. It is, but when it says update remote head, it's going to update the reference to the beginning commit. Head is going to be the most recent commit. It's going to be the current living last commit of this thing. No. So you don't always, no, you don't, this is an interesting, that's a good question. Do you always have to push to head? No, but kinda. Kinda. Because of the way that because of the way that you have to operate, I actually can't think of a scenario where you wouldn't be where, like, even if you're trying to update something, something at a different point in time, it's going to end up affecting the head anyway in the pointer of what that new first item is. So yes, you kind of are always pushing the head. And again, that head is just a reference. It's just a pointer. Difference between push and pull and merge. So pushing is taking stuff from your local computer and getting it and pushing it up to remote. So pushing is sending it up to the remote. Pulling, on the other hand, is taking down information that's been pushed to the remote that you don't have. So if you push something from your computer up to the remote, you don't have to worry about pulling it down. You already have it. You don't have to pull that stuff down. But if someone else, because multiple people are working on this thing, push something up to the remote, that common place, and you want to gather information from the common place, you can pull it down to your computer. So it'll go and grab all those changes and it'll pull it down to your system. And remember, friends don't let friends force push. Yes, with an asterisk beside it. I mean, yes, you might have to do a after you rebase, force push. It is, it's depends on your workflow. I wouldn't say never. I would just say don't do it unless you're supposed to. All right, so a bunch of words there. We threw out a bunch. Let's talk about the basic workflow. No, let's talk about the basic workflow. Let me see. Hold on. Okay, let's create our first repository. Let's actually get hands-on now. Let's create our very first repository before we do the basic workflow. We're gonna do this in two ways, okay? We're gonna create two repositories tonight. You can work out either one. We're gonna create one from GitHub first. We'll create one from the command line. You know what? We actually don't need to do that. I did want to do it both ways so you can kind of see how it was done, but they kind of coincide. I think we can combine them. What's up, Cyberbo? Welcome. Good to have you. So let's go ahead and create our first repository. Actually, we will do it two different ways, okay? We'll do it two different ways real quick. Let's start by creating a repository from GitHub, okay? So, no, we'll do that. We will do this. We'll do the second though, because it'll lead right into the next part. The next thing we're gonna talk about is cloning after the workflow. So we'll do that part second. So the first thing that we're gonna do is not create it there. We're gonna create something from the command line, okay? If you're not familiar with the command line, you can just do what I do here. So I'm gonna make, let's say, hey, I'm about to work on a brand new project and I wanna make it great. I'm going to go ahead and set up space on my computer to do that. I'm going to make a directory, okay? I'm gonna make a directory, mkdir. All right, this is gonna create a directory for me. When I do mkdir, I'm gonna say, our directory is gonna be called I'm gonna call it r_amazing_app. It does not matter what you name this directory. This is simply going to create a folder for us. Do I need Node.js to have command line on Windows? No. Europe. If you click on this and you type in CMD, it'll take you to the command prompt. If you installed it like this, you can also just go to Git CMD. Yeah, actually, if you install Git on Windows, just go to the Git command line, whatever it installed. So if you type in Git CMD, it should come up, and you can go ahead and do the same thing that I'm doing here. You could do it here. And actually, on Windows, I don't know if this is how it works. Okay, mkdir works on Windows as well. So I'm gonna call mine Our Amazing App. You can call it whatever you want. So mkdir, that's going to make a directory, and I'm gonna make a directory real quick, okay? Is Git CMD the same as Git Bash? I think so. I'm pretty sure it's the same as Git Bash. Yeah, if you're on a Mac, does this work for Mac? Yeah, mkdir, all the commands work on Mac as well. Yep, the commands are universal. Yeah, for like mkdir is, so for people who don't know, Macs are built off of Macs are built off of the Unix kernel. It's a Unix-like operating system. Linux is actually also a Unix-like operating system. So they're actually very, very similar, and they're very similar. So all the commands that we're gonna do here are gonna work just fine. Okay, so excuse me, sorry. Well, Private Christian Hacker, we are going to be doing a 3-part Linux series on Thursday. Thursday, Friday, and Saturday, we'll be diving into Linux if you want to do this. So I created this directory. I'm going to move into that directory now, okay? So I'm going to CD. CD stands for change directory. And I'm going to type in the name of this directory. So CD, our amazing app. That's going to take us into our new directory. If you want to know, if you want to be sure that you're in the right directory, if you type in pwd, it'll show you the place that you are on your computer, and I am inside of this directory, our amazing app. It also is telling me right here. Yours might not tell you that. If you're on Windows, I don't know if pwd works on Windows, but on Windows, it'll also show you this for sure. It'll show you your place right here. But oh, pwd does work in PowerShell. I don't know if it works on CMD. Okay, I don't know how to do it in command prompt, but in PowerShell it does. But if you are on Git Bash, you should be able to type in pwd, no problem. All right. Hit the red cup in the thermo. Got it. Hey, you gotta do what you gotta do. The yak and the Coke. Hey, it's just water. It's just water. You gotta. I got some coffee here with my name on it. You know, one day when this, I'm sure that when this baby comes and I'm stressed out, you know, I might got to do what I got to do. You all never know, you know, it's just, you never know what's in here. But right now it's ice cold water, you know, trying to be a little bit healthy, but one day that's actually a great idea. Never thought about it. Okay. Appreciate it. First one, gonna be exciting, you know, it'll be very exciting. All right. So we are in this directory right now. Git hasn't been used for anything at all. And so the very first thing we're gonna do is get set up with, we're gonna set Git up really quick. All right, you actually don't need to do this, but it's gonna throw a lot of words at you if you don't. So Git has a configuration. We're actually gonna dive into the configuration tomorrow a little bit deeper, but we're first gonna get a little bit configured. So that stops bothering us. So here's what I want you to type to get Git set up. It's gonna allow us to update the configuration file. Everything in Linux and Unix is just a file or a folder, honestly, or an executable. So it's not scary. We're not doing anything super amazing. We're gonna type in Git, okay? Config, so Git, config. This is gonna allow us to issue commands against the config. And I'm gonna do -- global. All right, so Git, Git config -- global. This is going to make the changes to the global Git config, because we could actually configure our own settings in the local repository, but we want to make these changes across the board. We need to tell our Git who we are real quick. So we're gonna say user.email, okay? All right, and then you're gonna do user.email, and then you're gonna type in the email that you used. You're gonna type in the email in there that you used to sign up with GitHub. Okay, that's all you got to do. So Git config -- global user.email, and then your email. This will set up globally your email so that when you are most of this is just so that we talked about that metadata, that little data that's going to be in there that's going to be about the rest of the data. It's going to set it up in a way so that when you do try to pull information and push information, it knows who you are, and it can better put the right things in the right places for you to be able to work with this. So yeah, baby won't stress you out. All the stress will originate from the wife. That is she heard that, and she didn't like that. That's all. I'm relaying. It's telephone. She said, hey, I didn't like that, so I'm just sharing it back. I was just reading. That's all. So stressed and funds a little bit. Oh, for sure. I'm well aware, except you all were very kind to us. Very, very kind to us. I think we got everything off of our registry. I think we got every single thing. even the stretch items. I think we got every single thing. So appreciate you all. Appreciate all my family. We have a ton of support, which is super helpful. A lot of people don't have that. So, you know, super thankful. Definitely right now it matters, you know, again, running my own business. You know, I'm no longer making that sweet tech industry money that I was making back in, you know, October. So, you know, it's all good. It's all good for now. So, you know, we'll be all right. But definitely gonna be, you know, I hear you, my man. Don't worry. I believe you. 100% believe you. What's up, Devlin? How you doing today? Okay, so this is the command you want to type in, and go ahead and hit enter. When you hit enter, you'll get no type of confirmation, no type of output. As long as it, you know, goes to the next line, you've done it properly. Okay, you've done good. Okay, that means it took. The next thing we're gonna do is git config -- global. So, you know, the command is almost the same. So git config -- global again, and then we're gonna go user.name. This can be whatever you like it to be. This is just an identifying name. Put whatever you want in here. I'm gonna put my real name. I'm just gonna put Aaron in here. And these are the two commands that you need to hit. Whoops. This is what happens when you don't spell things correctly. I spelled that wrong. So this is why I was saying, you know, if it just kicks you back to the prompt, you're good to go, but it'll give you an error if you ran into an error. So just, those are two commands. Git config -- global user.email, set up your email, and then user.name, set up your name, okay? Cool. You know, I'm happy you're doing this. I share with a bunch of people. Dope. I appreciate that. Dope. 100%. That is. I thank you so much for sharing. I hope, you know, the goal is to share as much knowledge as possible. I wish all CLI interfaces gave you the same similar commands. Yeah, I agree. They should, but they don't, unfortunately. So once you have those two things in there, really Git is ready to go. It would have actually worked most likely without you doing that, but it would have kicked out a bunch of warnings and stuff as well, and it would have been super confusing. And it actually might not have let us push the code. But once you do those two commands, you're good to go. Now we can do Git. Now we can really talk about Git. So the first thing that we need to do is we need some. Let's make a file, okay? Let's go ahead and make our own file. Now this is going to be, we'll do this in the easiest way possible. First, let's just add a file. Right now, if you do an ls, there's nothing here. Ls just lists the contents of this directory. There's nothing in this directory. It's not even a Git repository yet, okay? It's not even a Git repository, but let's put a file in here first. Let's start our code base, okay? So what I want you to do, all I want you to do is echo. Let's type this in, echo, and then in quotes, put your name or something. Put my name is whatever you want to type in, whatever text you want. I'm gonna say my name is Aaron. All right, put some quotes around it so you can put whatever you want in between here. Then I want you to do two little arrows like this, or actually just one. Just do one little arrow, and then type the name of a file. I'm gonna call this code.txt. So this command, this is a Linux command. You're gonna learn about this on Wednesday, Thursday, and Friday. Echo just is gonna spit out some text. And instead of spitting it out, this little arrow says, hey, put this text in that file. So without us having to modify a file, it should create a file. I'm not sure it's gonna create the file or not. I'm pretty sure it is, but it's gonna create a file called code.txt, and it's gonna stick this data in there, okay? So I hit that, I get no output, but if we do another ls, look at that. We have code.txt right here, okay? Yes, you can literally copy Blue Booger's command, and that will, it is a file, even though it says this is not a file, and that will do what we just did, okay? So now, there's a directory, there's a file here called code.txt, and if I look at it, if I cat what's inside of it, my name is Aaron is inside of here, okay? So we now have a file. We've started our code base, okay? You didn't need to do this to start a Git repository, but I wanted us to have a file to work with. You don't have to do this. If you want to copy, if you want to just drag a file, if you understand where your directory is on your Windows computer or your Mac or something, you can just drag a file into it if you want. But we've created a file now, and we do have a file here to start our code base, okay? Didn't the name of the email have to be the same as you signed up your account with? The email did. the email did. The name can be whatever you want it to be. And actually the email didn't need to be, the email actually did not, well, yes, it did. You can actually do some spoofing. It's wild. The Git is actually kind of weird in that way, but yes, use the same email that you signed up with. The name doesn't really matter. You can make it whatever you want. All right, so now let's now finally, after all this time, let's get into a Git. Let's make this a repository. Right now it's just a folder. It's a folder with a file inside of it now. Let's make it a Git repository. How do we do that? The way that you do that is with Git init. All right. And when you type in Git init, you'll get some output. And check this out. It says initialized empty Git repository in, and it'll tell you where initialize it at. And it should be a file path, and then whatever your folder you created was .git. So what in the world did this just do? All this Git repository is it creates this .git folder. It's a hidden folder in Linux. Things that are preceded with a dot, this is hidden. So actually, if you do ls, you won't see it. But if you do an ls-a, that's how you see it. It's for all, list all. And so this folder has a bunch of information in it, and we're actually gonna go in and look at it. You don't need to do this part. You don't need to do this part. If you're unfamiliar with command line tools, don't go into this part. I just want to show you what's here. You have this head file, which is just gonna be a pointer, and I can actually, I actually don't think this is gonna cut out anything. This is just gonna reference to what your current branch is, and it's got branches, and it has a config here. It has a description. It's got a bunch of other stuff in here, refs, objects, a lot of things that we talked about. But this is just a hidden folder. This is the little database that's keeping track of all of the history changes, okay? So you don't need to touch this folder. All right, I'm gonna get back out of this folder. You don't need to touch it, just let it be. That's the thing that's making this a Git repository. If you delete that folder, it's no longer a Git repository, okay? That's where the history, everything is held. That file, that folder is super important. Don't touch it if you wanna make sure everything is saved. So now, this folder is now a Git repository, okay? It's a Git repository. We did it. We made a repository, and now we can start the process of we can learn about the basic Git workflow, and we can start to use Git to be able to track this code. Okay, we just started new code. Now we want to track it. Let's talk about that. The basic Git workflow. This is the thing that everyone learns, and then they believe that they now know how to use Git. Yes, that's true. You do know how to use it now, but this workflow only works really when you're the only person working on a code base. Okay, but this is a workflow. You need to know this. You need to understand this workflow. It's actually a very short workflow. So it is only really 3 steps. It's 3 to 4 steps, 3 steps really. But in my book, it's 6 steps. So you're about to find out about that. Okay, so this is the first one that you might not see, that people might not tell you as the first step. That I will never not teach anyone Git without talking about this as the first step. Here's your second Git command that you, besides Git init, this is the next command you're learning. Git status. This is something you should get familiar with. How do we know what's going on? Let's make sure we know what the heck is going on, and that is with a Git status. So what you're gonna do is you're gonna type in Git status, okay? This will give you the status of a Git repository. That's what the Git status command does. So now let's look at the output here. There's a lot of information in the status. It says, hey, the first thing it says is we are on branch master. Remember, I told you to be either master or main. Master is how it gets set out of the box here. It says we're on branch master. What's up, RWX Rob? Welcome to the channel. Thank you so much for the raid. First off, if you all want to learn Linux, especially, even though we're going to be diving into it later this week, RWX Rob is an amazing teacher. Whoops, shout out. Actually, I don't know why I did that. RWX Rob, it's good to see you. Hope you're doing good. But yeah, the perfect person to follow if you all are trying to learn. Much smarter than I. I've learned so much from RWX Rob channel. So I appreciate you coming through. Thank you so much. So yeah, we're just, we're doing a 3-day Git session. Everyone from RWX Rob channel, we're doing a 3-day Git masterclass. And so, we've been diving through what is version control and understanding some of the terminology and stuff. And right now, we're just learning the basic Git workflow. We just created a folder, we just put a file in it, and we just initialized our repository. But now we are learning the main Git workflow. Mine is 6 steps. Most people's is 3 steps. We're doing this. So the very first step is the Git status. You got to know what's going on. So it tells you what branch you're on. Remember that branch is going to be, that different lineage of history. Okay, same code base, different kind of lineage, different path of commits, different path of snapshots. All right, so it tells us we're on the master branch. There's only one branch out of the box. Until you create more branches, that is all you have. So back in the folder. So yeah, CD is how you get back in the folder. So you CD back into the folder. If you went to the .git folder, CD ... will take you back one. Can you do a masterclass of streaming on Twitch? I could try. Yeah, I can. I'll share everything that I've learned over the years for sure. I will do my best. All right, so this is good to know. It is really important for you to know which branch you're on. So let's just know that, hey, you're on the master branch. Cool. Then it says no commits yet. What did we say commits were? Commits are those snapshots. That's the point in time change of the history. Okay, that is a point in time reference to a historical change of this code base. So there are no commits currently. All right, nothing's here. But then they say, hey, we have some untracked files. And then it gives you a little helper text here that tells you what you should do. Untracked files. These are files that Git, so this directory is a Git repository, but it does not automatically track everything that's in here. All right, it doesn't just automatically track everything that goes in here. You have to be explicit about what you track. All right, so right now it says, hey, I see a file here. I see the code.txt, it's here, but I'm not currently tracking this thing. It's available for me to track. I can track it for you if you want. And so if you want to, you can do a git add file to include it in what's going to be committed. So the very first thing though is git status, but that's now you should kind of, hopefully you'll forget everything we just said here, but that's just a breakdown of what you see here in the git status. It tells you what's going on. So utilize git status heavily. All right, know what's going on. So that's step 1, always git status. Now, step 2 is to stage your changes, okay? So after we know what's going on, we need to tell Git what things we would like to include in our next snapshot. The next time we are taking a history, we're creating a point in time, we're writing that history down, we need to tell it what to track, okay? And that's where we use the add keyword. So git, add, and then the things that you would like to add, okay? So let's go back in here and we're gonna do a git add code.txt. All right, git add and then the file name that you want. So you will commonly see in tutorials, all right, you'll commonly see this git add dot. All right, this is not wrong. It's not wrong. I don't want you to get into that habit right now. If you're first learning this workflow, this dot, the dot right here will add every single file that is in the current directory, okay? This can be dangerous and this can be problematic. It is okay. No, everyone does it. You are, Robot is completely okay. You are not wrong. There's nothing wrong with it. Well, if you get into the habit of using git add dot, you will one day on your job commit a bunch of files that you did not mean to commit. You will, guaranteed. And a lot of it is not because of your error. Sometimes it's because of maybe we were adding something new to this repository and we were testing something out and we didn't add this new folder to git ignore and I accidentally added everything in here. It can be a problem. It will happen. It'll happen if you use git add dot. It's okay to use. I use it, but I want you to understand that it adds everything. So be careful with what you're adding. What's up, Ilelo? Thank you so much for the follow. I appreciate it. So git add, and right now, I want you to add the file that you care about. You can, if there were more files here, you would just add all of them like this. File2.txt, file, whatever the file name is, file3.txt. You can just add them all like that. Yeah, you can add them like that. But the git add dot, just be careful. It works, but just be careful with it. Yep, or Git dash A. Yep, that works too. It is okay. Just know you might make some problems here. All right, so now I'm gonna add this, okay? Now it is staged to be committed, okay? It's Git now is like, hey, I wasn't tracking this thing before, but now I am. I'm tracking this thing, I know about it, I'm staging it so that when you go to do a snapshot, I'm gonna include it in a snapshot. I'm gonna include it in the picture. I'm not gonna crop it out. I'm gonna keep it right there in the picture for us. So that's what we gotta do there. All right, so what's our workflow so far? Git status, know what the heck's going on. After we know what's going on, go ahead and add the files that we would like to track. You only need to add files to track once, okay? You only need to tell Git to track the history of a file one time. All right, so now that we've added it, we're good to go, but that doesn't mean that so I take that back. I'm sorry, I take that back. I don't know, I actually don't know why I said that. Take it back. You need to tell it if you've made modifications to a file, you need to tell Git that you're ready to add it to the history whenever you want to change it. Because sometimes you might have changed 10 files, but you're only ready to change the history of 3 of them. And so you need to be explicit about the files that you're ready to change. So you add it, so you Git status, step 1, Git add is step 2 to stage those things. Step 3, what is step 3? That's probably not what you expected. Step 3 is Git status again. This is not the normal Git workflow, but I put Git status after every step just to get you in the habit of getting going with this thing and understand what's going on. So after every command you do in the workflow, I want you to type in Git status, okay? Things are different now. The code base is actually different. Git is in a different state right now. Let's make sure that we are doing what we intend to do. You wanna make sure that you're not making a mistake because it can be very difficult sometimes to fix your mistakes. That is where Git gets tough. So let's make sure you get it right. Yes, the ego, yes. Check yourself before you wreck yourself. That is absolutely what it is. So Git status. And notice how it's changed. We are still on branch master. That's good. No commits yet. There's no snapshots yet. Okay? Changes to be committed. Before it says, hey, I have untracked files here. Now it says, hey, I have changes. I see that there have been changes made. And a whole new file is here, which is code.txt. So I'm gonna, I'm gonna commit this whole brand new file. And it says, hey, if you made a mistake and you want to take that thing out, you can use git rm. We'll learn about that a little bit later. Don't worry about that right now. But now it's saying, hey, you have a file that's going to be committed. So if you see green, that means that thing is going to be included whenever you take a new snapshot of the history. It's going to be included. Okay, so Git status, Git add to stage those files. Git status again. After you know what's going on, after the add, you've been confident that you know what's going on. Now we're going to now take that snapshot. So now it's time to record this moment in the history books. All right, let's create a snapshot of our changes by committing our code. That's the keyword, commit. So a commit creates that point in time reference to the history here. So it's going to record the changes. We've made modifications. The way that you save those changes, the way that you make sure Git is able to track those changes is you must commit them. All right, and that takes a snapshot. So here we go. The way that we do it is Git commit. There's a -m here. -m stands for message. And then you want to put in here, hopefully a meaningful message. The reason why I said hopefully a meaningful message is a lot of people are awful at commit messages, but it's okay. These are very helpful. Do yourself a favor and do your best to make descriptive, as descriptive as possible commit messages, because these messages tell you what this change was, this time in history, why are we, like, what happened here? What happened during this modification? And so you want to describe what happened in the current set of modifications. So now that we're ready to go, we're gonna do a Git commit -m for a message. And our message is gonna be added initial code file. Sure, whatever. Doesn't matter what tends to use it. And so it doesn't, every team might have different ideas about what goes into their commit messages. But right now we're just gonna do this, add an initial code file. People write all kinds of things. Fix stuff is absolutely one. I wrote a lot of fixed its, you know, especially for my own use cases, but do your best to be descriptive for other people, especially if other people are working on this with you. Try to be descriptive about what happened, because if these are point in time references, you can go back to these point in time references. And if you can easily identify when something happened, it's much easier to go back to when you needed to. Okay. Thought it was cute. Might delete later. Hey, it's a commit message. We type that in. Let's be clear. You have now changed the history of this code base. You have permanently changed the history of this code base. Okay. You've done the do now. The database has been updated. You have created a new historical moment for this code base. Okay. Look at what it says. You know, it adds a unique hash here. It says added initial code file. One file was changed, one insertion. So it says one insertion because I only changed one line of code. If I changed 10 lines of code, or added 10 lines of code, it would say 10 insertions. All right. If I removed 9 lines of code, it would say -1. I don't know. I forgot what it will say. And it says create mode. The reason why it says this is a Linux permission. You'll learn it on Thursday or Friday. And it says, hey, this is a brand new file. We created it here. And so we're good to go. So we changed the history now. We did it. Okay. We changed it. I actually don't know that there's a limit. So 50 characters, maybe. I didn't know that it was 50 characters, to be honest. I never write one that long. So, okay. So I hope you all can guess what the next step is. After we say cheese, what do? We do the status again. Make sure you're good to go. So git status. Just to make sure you're good. It says on branch master, nothing to commit, working tree clean. That means, hey, we're good to go. We have updated everything that we need to update. We're good to go. If we try to commit again, there's nothing to commit. We haven't made any changes. This only tracks changes. So we're good to go. We won't see anything in git status until we make some more changes. All right. So cool. We are clean. We're good to go. The last step here in the basic Git workflow is git push. All right. We've made all those changes. Now we've changed the history. Our computer has the history now. It's the source of truth. We want to get these changes up to the remote, to the common place. The way that you do that is with the git push command. So we need to take this and we need to push it up. Yeah. So always pull before pushing. Yeah. I think that is a fair assessment. I think that's a fair assessment, because yes, you can do it. I mean, us doing that's not going to do anything because we can't pull. We can't pull because there's no remote. Okay. So I'm going to type in git push. Okay. And it's going to give me an error. It's going to give you an error. All right. It says either specify a URL from the command line or configure a remote repository. So right now, the error that it's giving is saying, hey, you tried to push, but like, I don't know where to push this stuff to. I don't know what the remote is. Where's the remote? This is where GitHub comes in, okay? So let's go back to GitHub. Let's go in here. And again, if you're not on this page, click your face over here or your icon, go to your repositories, and we're gonna create a brand new repository. All right. As a template here, don't worry about that. Leave it on no template. Here's what we're gonna do. Call it whatever you want. All right, so repository name, type whatever you want. I'm gonna call this tracks. I'm gonna call it tracks dash March dash 2021. All right, you can call it whatever you want, but it must be unique in your repository. I mean, in your account. Okay, so I'm gonna call it tracks March 2021. You call yours whatever you want to call it. Doesn't matter what you call it. Description's optional. You can do it or you cannot do it. I'm just gonna say this is our example repo. Doesn't matter what you put in here. It's optional. It should be descriptive of what this thing is. Public means anyone on the internet can see it. Okay, that means you all can see it, can access it, can pull this code down. Okay, great. Now, don't click any of these. You don't need to worry about any of these yet. Don't click any of them. This just gives you some extra options to start your repository with, but it doesn't matter. All right, just put the stuff here and click create repository. Now, once you create it, you now have the same way that so here's what happened is the same way that we did a git init in our own computer. That's basically what just happened at GitHub. GitHub servers set up a space in our account and it did a git init. It set up a repository for us to now be able to interact with, okay? So I've got a repository, they've got a repository. Now we have to point to this as our remote. So the first thing says, hey, if this is brand new, this is how you kind of get started, but we already have an existing repository, okay? We already have one here, okay? So all you gotta do is copy and paste the commands that they gave you. So let's talk about what these things are. You take the first command. This first command is how you add a remote. Okay, so it's gonna add this remote URL and it's gonna set it up in the configuration for this. So you type it in, you hit enter, pretty easy. That now tells this repository where it can push stuff to and where it can pull stuff from. All right, then we can do this. So this is going to change the default branch to main. So Git set it up as master. This is actually going to set it up as main instead. So paste that in and it's actually going to change the default branch to main instead of master. And then you take this and now it's going to push the code up. And so when you hit this git push command, you then have to authenticate with GitHub. You can't just push to anybody's GitHub. So I type in my username and I type in my password. When you type in your password, it won't show you typing because that's how passwords work in Linux. So just keep typing it. It's not gonna show it to you. And when you do that, it will now take your code and it will push these things up. So counting objects, 3 objects, writing these objects, it says, hey, I'm setting up a new branch, main. And now when you go to this page, go back to GitHub, just refresh the page. And now your code is right here. Your file is right here. You can click on it and actually see what's inside that file. You can also see the entire history of that. And the only history is that we added initial code file. That was my commit message, okay? So currently everything's here. All right, the history, the files, it's all right here. Definite Optimist, thank you so much for the tier 1 sub. I appreciate that. I really do. That makes me, that's love right there. I appreciate it. Shrek Gould, thank you so much for the Twitch Prime sub as well. Thanks for the love. Thanks for the support. Congratulations on not having to watch any more advertisements. All right, so we've now created a repository. We've now pushed to that repository. So if we were gonna make a change, let's say we made a change to our file. All right, this part, not super important. Just want to show you focus on the workflow, not on us changing the file. So if you want to make a change to the file, I'm going to open it up just so you can see me doing it. I'm going to make a change. It says, my name is Aaron, and maybe, maybe I just want to type in some extra stuff. Maybe maybe I'm writing a book. I don't know, just typing it out here. We've now added some stuff here. Great. We've changed this file. I did it in Vim. You can do it in Nano. Don't do it in Vim if you don't know how to use Vim. If you want to make a change to the file easily, Shift ZZ. Why is the next thing? Oh, because I have caps lock on. Okay, if you want to add stuff and you don't know what to do, go back to the echo command, or just type in echo. Type in what you want to add to it. So let's say you want to add. Here's a new line. I can't type. Whoops. So echo and whatever code you want to add in. And so yeah, you could touch the file, but if you touch the file, I don't think that Git will see it. I don't think Git will see it. Okay, if you're really stuck in Vim, you have a couple options. Hold Shift and hit Z twice. That's one way. Hold Shift, hit Z twice. So capital Z. Or you can do :X. That'll do it too. Control Z will get you out, but it will not save the file. It won't exit Vim either. So if you did Control Z, it's running in the background now. So be careful with that. And then you have to get back into it by typing FG. No big deal. Or you can use :WQ to save and quit, or :Q exclamation point if you just want to get out of there. Okay. But yes, Control Z does work. But it puts it in the background. Or you can do the echo command. Just make sure if you do the echo command that you do, if you want to add to the file, make sure you do 2 of these arrows instead of 1, or it'll overwrite what's already in there, and then the same file, okay? So that's just gonna append it to the end there. But I've made some changes. I've made some changes to the code now. All right, so imagine the workflow is, okay, I've been tasked to do some work. I go to the computer, I sit down, I make, I have the code, I make changes to the code, I update my code accordingly. Then when I'm good to go, I say, hey, I want this code to be saved. Here's the workflow. I've made some changes now. What do? The workflow, git status. All right, and so git status says, hey, I'm on this branch, but it lets me know that I've modified this file. There's been some changes made, but they're not staged. Do you want to stage those changes? Yes, I do. So I'm gonna add that file. I'm gonna do git status again. It says, cool, you're still in the same branch, but you made some changes and now they're ready to be committed. I say, cool, I now know what's going on. And so I'm gonna do a git commit. All right, so I'm gonna say git commit, added a bunch of new code. All right, and it says, look at this, 11 insertions. I added 11 new lines of code here, but I only changed 1 file. If I change 10 files, it will let me know that I changed 10 files. This is a good little summary of what was done. But now I have changed the history. The history has now changed, but it's only changed locally. All right, it's distributed. So my computer knows about this change. GitHub does not know about these changes. All right, so how do I make sure GitHub knows about these changes? How do I exchange these changes with GitHub? Git status again, make sure I'm good to go. I'm good to go. It says, hey, you're ahead of origin main by 1 commit. This did not show up before because we did not have a remote yet. Because we have a remote, because we have another repository that we're kind of connected to, it says, hey, you're actually ahead of that. You're actually, you're actually completely ahead of it, okay? So do you want to synchronize these things up? If you want to synchronize these things, do a git push to publish these things. And so git push, okay? So put in your information. So what's the workflow? The workflow is, okay? Workflow is git status, know what's going on. Git add, stage the changes. So make some changes to the file, add it. Git commit, which is gonna change the history, add a message, okay? So git status, git add, git commit, git push. 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 That's it, okay? That's it. That is the workflow. Git status, git add, git commit, git push. That's the basic workflow. Git status, really, git status, git add, git status, git commit, git status, git push. Git status, git add, git commit, git push. Git status, git add, git commit, git push. Commit that to memory, okay? That is the basic workflow. That is what you are always gonna follow those things, okay? You're always gonna follow, like no matter how tough it gets, that is the workflow that you're gonna follow. I take that back. You will do all those things. There might be other steps in between, but that is the basic Git workflow for what you wanna do. Okay. Oh, actually, so it failed because I didn't type in my stuff correctly. That's also, so you saw that this failed and I didn't notice it at first. That's the git status. If I did a git status again before I just fixed it, it would have told me that, hey, like you're still ahead of master, and it'll tell me that I need to go push some stuff before I get going. All right, that's the basic workflow. Let's knock out the last 2 things real quick. Last 2 things, real quick, cloning. This is a great thing, it's exciting. So cloning creates a copy or a clone of another repository. Okay, it takes a full clone, of another repository. It also sets up remote tracking for all the branches in the clone repository. So you saw us, we created a repo, and then when we made some changes, the very first thing we had to do to set it up is we had to tell it what remote to connect to. Cloning will say is whenever you want to gain access to a repository and its full history. Remember we said distributed, you can, everybody's repository has the full history of all the files. The way that you get access to those things is you clone it. And not only does the cloning grab the full history as well as all the files, it also sets up remote tracking so you don't have to set up those remotes kind of does it automatically for you. So how do you do it? You go into GitHub, you find a repo that you care about, and then you grab the URL and you run git clone and paste in that URL. So I'm let me give you one of my repositories. I'll give you one that you can, the Pokemon one. Let's do that one. Hold on. Let's if you guys want a cool Pokemon Python game, Pokemon Yeet. We created a game called Pokemon version Yeet. So if you want to play a command line Pokemon game, it's dumb. It's not, we made it in 2 days, and so it's not full featured, but it's here. If you want this code in the full history, why is there only, hold on. Oh, there's only, actually, let me give you a different, so you can clone this, but I do want to give you something with, actually, take this for now. You can take this. The way that you get this thing, all right, if you want it, I'll give you this repository. You can find any public repo on GitHub. So if you have one that you would like to clone, that's fine. What you do is you grab the green button. Remember I said green here is gonna draw your eyes, and you're gonna grab this URL right here. And all you're gonna do is copy it. Just grab it, copy it. Head over to your computer. Make sure you're where you want to be. Don't clone. Whoops. Do not clone this. Well, I won't say do not. Likely you don't want to clone this inside of another Git repository. So I would get out of this repository. So just do cd ... to go back one. When you clone this code, it will make its own folder. It'll make its own folder. That's the name of that's actually the name of the repository. So I'm gonna type in git clone, and I'm gonna paste in the URL that I just copied, okay? So you can see here, notice it ends in .git, and I'll hit enter, and look at that. It gives us some information about what it did. And so it cloned this, it pulled this down, and if I do an ls, I have a Pokemon Yeet directory set up right here. And if I go into Pokemon Yeet, I have the files that I'm supposed to have, okay? They're here. So I now not only have the files, but I have all of the code. And now it's actually set up. It's set up right now for me to be able to make changes to this thing. You won't be able to make changes to it because you'll be able to make changes to the code locally. But if you try to push to my remote, it will fail because I haven't given you access to push to it. But you can make some changes. We'll talk about how that works a little bit later. We'll talk about forking and stuff tomorrow, actually. But cloning, you can take it, and now you have the full history. You'll have all the branches and all the things that you need, that you could start to work on this or take this code and do whatever you want to do with it. All right, so that's all cloning is. No big deal. I'll send a PR for code.txt. Yeah, I'll save that for tomorrow for sure. Cool. So that is cloning. That's all you need to know about cloning. So when you walk into a new company and you're there to be a developer, one of the very first things that you'll do after you get all set up with your stuff, you will go and clone all the repositories. They'll give you access to all the different projects and things that they have, and you'll clone it onto your computer so you have the full history so that you can now begin to contribute to this thing. So that's what cloning is. And last thing is branching and tagging. We'll probably talk about tagging a little bit more tomorrow, but branches, we already talked about branches. We talked about branches being this separate lineage of code, the separate lineage of history. Let's go back to the repository that we created. So I'm gonna go back to that directory. So I'm gonna go back one. All right, and then I'm gonna go into our amazing app. So I'm gonna move back into this folder. All right, once I'm in this folder, let's talk about branches, okay? So branches are simply a pointer to a series of commits. So that is really what it is. So remember how we said a branch is a new lineage of this code base? A lineage is just a series of commits. What makes up a code base is a series of changes. And so a branch is just a pointer to a different series of commits. Think different branch of history, manage branches via the git branch command, okay? So if I want to, if I type in git branch, it will tell me what branch I'm on, and actually I don't think it'll list all of the local branches, unless I do something like a -A, which will show me all of them. Whatever, git branch will list your current branch if you want to see what current branch you're on. If you want to create a new branch, okay, you do this in two different ways. The first way, if we want to make a new history to track what's going on, let's go git branch, and then the name of the branch that we want it to be. So I'm gonna say I'm gonna call this, I'm just gonna call it development. You can literally call the branch whatever you want to call it, okay, except for main, because main's already being used. So I'll type in git branch development. This creates a brand new branch. So if I do a git branch or git branch ls, I can see I'm on main. That's what the star is for. But development branch is here and it's available. So if you type in git branch and the name of a branch, that's how you create a new branch. Okay. If you want to delete the branch, you just do git branch -d -lowercase d. We'll delete a local branch. We'll dive deeper into these things. Just giving you a little bit right now. And so you can see deleted development branch. You cannot delete a branch that you're currently on. So if you want to delete a branch, you have to change to a new branch and then delete it. But let's make a new branch real quick. Let's recreate that. So git, actually, before I do that, the other way to do this, actually, let's make it again. Let's do git branch development. That creates the branch. So git development branch is here, but I'm not on the development branch. Remember, git branch is how you see what branch you're on, or you can type in git status. And it lets me know that I'm on branch main. If I want to switch to this branch, I have to check it out. Remember, we talked about like the library. If I want to work on those files, if I want to now be working on this branch, I have to check it out. So I'm going to do git checkout. All right. So, nice and easy. Git checkout and the name of the branch that I want to check out. Okay. So git checkout development. Git switch. I don't even know what git switch is. I don't even know what that is. Hold on. I'm about to look that up now. What's up, Richard Bird? Thank you so much for the Twitch Prime sub. That's love right there. Amame, thank you. So 3 months, amazing. I appreciate it. Thank you so much for the love. I actually don't know what git switch is, but I'm about to find out right now. Oh, it's new. That makes sense. I've never heard of that. Yeah, we can read. Let's look at the man pages real quick. So notice right here it says switch to branch development. So now I'm on the development branch. If I do git branch again, I'm now on the development branch. Notice how, so I created a branch, and once I created the branch, I then had to check that branch out. I had to, create it, then I had to check it out so that I could work on it. You can actually do that in one line. The way that I can do that, I'm gonna switch back to main. And so how do we do that? We do a git checkout main. Now it lets me know I'm on main. And then if I want to if you want to create a branch and check that branch out immediately, the way that you do that is git checkout, and you'll see this a lot. -b. So instead of using the branch command, you say git checkout. The -b will say, hey, create a new branch, and maybe I'll call this the staging branch, whatever, whatever, or I'll call it a production. I'll call it a production branch. And so if you do git checkout -b, it will create the new branch, and then it will immediately check that branch out. So if I do another git branch, I am now on the production branch. So I have 3 branches now. Right now, they all have the exact same history. Why? Because whenever you create a new branch of history, you have to branch off of something. Tree branches, they come off of the trunk. Okay. The trunk here is main, or at least what I've been using is main. So when you do a git branch and the name, it's going to branch off of whatever the current branch you're currently on. It is going to create a new branch based off of that. So when you first create it, the new branch and the branch you branched off of will have the exact same history. Okay. The exact same history. That's what it'll do. So you have to be careful with which branch you're branching off of, because you can make a new branch off of any branch. But this creates a new branch, and they can go in their own directions now. Different commits can be committed to each one. All right. And so what I'm going to do now is I'm on production right now. I'm just going to add a new file real quick. So let's echo again, and I'll echo it into new file.txt, whatever. I'm creating a brand new file, and now I have brand new code in here, but remember, if I do git branch, I'm on the production branch. I'm no longer on the main branch. And so I'm going to run through my workflow. I'm going to do git status. See, I have a new file. I'm going to add it. Now that I've added, I'm gonna do git status again, make sure I'm good to go. It's now green, looking good. I'm gonna git commit, added, brand new file. All right, and now that I've created it, I'm gonna do a git status, and I'm gonna do a git push. So when you do a git push after creating a new branch, the very first time you create a new branch, it has to set up the remote per branch, but it'll tell you what command to do. So it knows what the main remote is. So it says, hey, I need you to type in this command first. You only need to do this the first time, but just copy it and paste it, and you're good to go. And now it's up here. So if we go to our page and we refresh, whoops, let's go back to our other repository, which was, so our repository right here, look, we're on the main branch right here. This is where it shows the branch. That new file is not right here. It is not in the history of the main branch. But if I change it to the production branch, new history, same code base, new history, it is now in here, okay? And so if I wanted to get this into main, I would have to merge it in. We'll talk about that a lot more deeply. But yeah, I have different histories. That is what a branch is. But you can also see in the same section here, there are these tags. So let's talk about tags real fast, then we can get out of here. Tags, what are tags? Tags, branches are new, branches are a series. They're a series of commits. Git tags are a pointer to a specific commit or moment in history, okay? So that specific commit or moment in history actually references a bunch of other things as well. If you all are familiar with linked lists, if you're into programming and you're familiar with linked lists, a Git repo, Git history is really just, it's just a linked list. It's just a bunch of nodes pointed back to other nodes that are linking them together, to be honest. But Git tags are a pointer of a specific commit or moment in history. So instead of pointing to a series of commits, it's pointing to one specific spot. You can manage these tags via the tag command, okay? And so some people use these. You might say, oh, what would you use these for? If I want to highlight a specific, tag a specific commit, maybe I want to tag a release. Maybe like, okay, at this point in time, this is where we release version 1. So I'm going to create this little tag that points to this specific commit that has all of the things needed for version 1 of our application. As we're ready to deploy number 2, I can tag that with a brand new thing. Releases use tagging. And so we can also use tags for that. And I can tag any commit with a tag. And so the way that you do that is git tag and you give it a name. So maybe I want to give it version 1.0.0. Okay, so git tag and then the name of the tag, and it tags it with that. And now, if you want to push your tags, and so we can do a git status. Doesn't really tell you anything because tags are a different thing here. And if you wanted to push them, you have to do git push -- tags. That is how you push the tags up. And I'll authenticate. And it will push the tags up. New tag. If you want to see tags, you can just type in git tags or git tag, not gat tags, git tag, just tag. And it'll list out all the tags for you. But this is just a pointer. A tag is just a pointer to a single commit, okay? And each commit though is actually pointed back at another set of commits, and that's how it knows the full history. But now if I refresh this, a tag is not a new lineage of code. It is a pointer to a specific place. Okay, get tags. That's the perfect emote for that. I love that. Got my get tags and tag. Yay! Gotta do what you gotta do. I might have to alias that, and we might have to, maybe we'll change this to tracks, which is a Git MASTERCLASS. That's probably against some type of terms of service, to be honest. Yes, alias to get to Git. Seriously, I might have to now. That's Let me see what the legality of that is. Let me see if I'm gonna get in trouble by Twitch for doing that. I don't want to go. I don't want to get my channel banned because of a joke. They might say, we're promoting violence or something. We're not. One day we'll see Mastermind 5. Hey, yes. It is what it is. It is what it is. So That tag simply points to a specific commit. That commit is a very unique ID, and that will have everything at that point in time. So it's just a pointer. Tags are just used as a pointer to a point in time. They are not branch specific at all, but it points to one specific commit, and every commit is unique. Every single one gets a unique ID that points back to another series of commits. It's pretty interesting how it works. But branches, new lineage, new series of commits. Tag points to one specific commit, and that's everything. That's everything today. So what are the tangible takeaways for today? Tangible takeaways are version control. Okay, how do we manage changes? How do we understand and track the changes to software? That is what we are learning Git for. How do you track changes to software? Through version control or source control. The tool that enables this for us is called Git, created by Linus Torvalds back in 2005, originally created so that he could help with the development of the Linux kernel. And so this technology allows us to track the changes of a code base by creating patches and exchanging those patches in a distributed manner. So it allows distributed teams of developers to have the full history of a code base. And to be able to exchange patches to synchronize them together, which allows, again, for non-linear workflows. We don't want linear workflows. We don't want, overlapping. All of us want to be able to develop on this at once so that we can do it quickly. But how do we do that? And how do we work on it in a separate way and then bring it back together successfully? What we'll be learning for the next 2 days is really how that last piece of how we do things separately and bring them back together and get it all nice and tidy together. That's the hard stuff, to be honest. And so Git allows us to do that. It gives us all the tools that allows us to do that efficiently and effectively. We learned about Git hosting repositories, repository hosts like GitHub, like GitLab, like Bitbucket. We learned that Git is not the same thing as GitHub, not the same thing as GitLab, not the same thing as Bitbucket. Those are services that utilize the Git technology to help us manage our repositories, but Git is the technology that allows us to do those things. We learned about branches. We learned that branches are different lineages of a code base, and tags to point to a specific commit. We learned a bunch of different terminology, we learned a bunch of different terms, a bunch of different words that help us understand what Git is and how it works. And so, take your time, go over these things, look back through, hit slides if you need the slides, exclamation point slides, go back through, look at some of these things. There's a lot of other terms that we're going to learn throughout this course. Git can get super confusing, but you've learned the basics today. You've learned what it is, and you learned the basic workflow. Git status, make sure you know what's going on. After you know what's going on, you make the code changes that you need to make. Once you make those code changes, you stage those files. You say, hey, I'm ready to save these files to the history, so you add them. So Git status, then Git add. After you add them, you say, I'm ready to take a snapshot. Let's add this to the history. With Git commit, commit is how you snapshot it. Git commit -m, you add a message. After you commit it, after you change your history, you want to share that history with everybody else. So then you push it up to your remote. So Git status, Git add, Git commit, Git push. Git status, Git add, Git commit, Git push. One more time, Git status, Git add, Git commit, Git push. And all the rest, a little bit extra. That's the basics. You can get by for a long time off of just knowing those. I'm telling you that from experience. It gets tougher when you're working with a team, but I got by for a long time knowing those basic things, understanding what branches were, and just doing my workflow. Okay? So that's it. What are we going to learn tomorrow? We're going to dive a lot deeper. We'll talk about SSH versus HTTPS. I'll teach you how to get your SSH key set up. So this is more, these first two things are GitHub related or Git repository hosting related rather than Git related. Then we'll dive into we'll get into the more intricate things. Like, how do we compare differences in our current code base? How do we see what's different? Maybe when we did a Git status, we saw a file that was changed that wasn't supposed to be changed. And how do we know what changed within there? How do we know what it used to be? How do we know what changed? We'll learn about pull requests and how do we start to merge those files back together, how we start to, combine those files back together, those histories. We'll figure out how to take other people's code and contribute to it and all that other stuff. And it should be pretty excited. What's up tomorrow? 7 p.m. Eastern time. All right. So 2 hours and 35 minutes before right now. And yeah, that's what time. Doing the pushes, doing the workflow, working and having, yes. Okay, that's it. And then yeah, we'll do a little bit more fun stuff on day 3. If you go to academy.mastermind.io/waddle, I think that should work. Okay, that does not work. Let me just give you the link. If you're interested, yeah, join the Discord for sure. There's people there. Ask some questions. You know, if you need help with anything, that's the place to be. Let me give you the other excursion. Waddle will start on Wednesday. Foundations in Linux. It's going from a 6-parter to a 3-parter. It might need to be a 4-parter. I'm trying to make it work. But it needs to be a 3-parter because we're trying to do some other stuff with containers after that. But if you want to see what that is, I don't have a special page for this. But this stuff is old. But I'll send you this. This is old stuff. But the Linux stuff, there's a lot in it. We'll probably skip over, well, yeah, we'll do a bunch of Linux stuff starting Wednesday, Thursday, Friday. And the Linux stuff is interesting because it can go on for forever because there's so much Linux stuff. But yeah, that's when we'll cover that. And then next week, we'll be doing Docker and Kubernetes as well. So if you're interested in that, come back through next week. But thanks everybody for coming through. I got to get out of here. I appreciate you all. And for all of you people who've been waiting on YouTube stuff, half of the videos, the copyright strikes are off of half of the videos. So I'm going to enable those tonight. I'm not gonna wait for all of them to be done. They're the first half. They did it in order. So the first half, most of the next ones are there. And then the last 6 or so are, 2 of each course they need to clear. I'm hoping that'll be done tonight or in the morning. I'm not sure. So you should see some YouTube videos if you're still waiting to catch up on some of those things. Those will be there. So we're almost through it. And I will try to get this up tonight as well, so people can see it. But that's it. Who are we going to head over and raid this evening? Absolutely gonna do this. Thanks for coming through. Whoa. CFX.re, we develop tooling enabling enhanced experiences. Hold on. What is this? Oh yeah. For GTA, I've seen this. Yeah. Hey, you gotta have a good time out here. I like games. I like games a lot. All right. So who's on? Let's see. Front-end developer learn cybersecurity. I don't know this person, but we are going to. I think that's who we're gonna go see. And actually, now I feel bad because I just lost I clicked on it to go to the section, but I don't see Chris Sean. Never mind, not Kristen. Chris Sean. There we go. So we're gonna raid Chris Sean. Say hello. Front-end developer trying to learn some cybersecurity. I'm terrible at front-end dev, so but I know a little bit about cybersecurity. Not a ton, but I can get around. I can definitely get around. So let's go see what Chris Sean's learning. I wonder if his name is Chris. Actually, I have questions. Is it first name Chris, middle name Sean? Is the whole first name Chris Sean? It could all be. I've never seen Chris Sean spelled that way. I've heard the name Chris Sean before, but never seen it spelled that way. So let's go ahead and see. But thanks everybody for coming through. Hold on. What's AWS doing? What are they doing? Whenever they're on this late, they're hit or miss. It's Chris Sean. Okay, now we're gonna head over to Chris Sean. We're not gonna pull this stuff. AWS, I'm over there a lot. We're gonna head over to see Chris Sean, and we're out of here in 10, 9, 8, 7, 6, 5. Yeah, I mean, we'll see what Chris Sean's doing. 4, 3, 2, 1. Thank you, everybody. I will see you another day. Peace out.